My name is Dylan Bennett. I am with PIGSquad, and I help organize it along with Will and Marlo and Corey and a bunch of other people. So today we're going to be doing a Learn to Code workshop, and this workshop assumes nothing. We assume that you've never learned to code before, or maybe you have tried to learn to code and just kind of never stuck, but we assume, can you open a web browser? Yes? Good. Then you have everything you need to know. And I'm here with JJ. JJ Gonzalez is my friend who has wanted to learn how to code and has never done so before. So I thought this is perfect. Maybe we can do a workshop where together we are both going to be doing the workshop. I'm going to be delivering it to him and all of you. But he's going to be doing this live, and I think that will make this a little more interesting. So first off, before we get started, just a word about PIGSquad. PIGSquad, Portland Indie Game Squad, is a nonprofit based in Portland, Oregon, and we serve as independent game developers in Portland and the surrounding areas by providing workshops like this and events, social events, and just mainly a platform for independent game developers to connect up and, do lots of things related to independent game development. We have game jams. We have a game jam that just wrapped up. We have another one starting soon, our summer slow jams. Definitely go to pigsquad.com and check out the calendar there to see all the events that are happening. Okay, so JJ, you've never coded before.
Never.
Okay, good. So I'm gonna assume that, and we're gonna start at 0. So first off, I just want to talk about coding in general. What we're gonna learn here is we are gonna be learning the Python language, which is an extremely popular language. It's, I think, one of the most used languages right now, and the reason I like it is it's easy to learn. It doesn't take a lot of work to learn it. A lot of parts of it kind of read like English once you kind of know some of the bits about how to read code. Nice. And it's pretty easy to learn. And there are just tons of tutorials and help out there for pretty much anything. So if you want to learn how to do something, most of the things you can just Google and you'll find lots of things out there that explain how it works. The other thing I like about it is that it doesn't take a lot to get up and running. You don't even need to install anything. So, for example, to get up and running today, we're just going to be using a web browser. We're not going to install anything on a computer. I think you're using a Chromebook right now, so it doesn't even, it's just a web browser. So the way this is going to work is let's get started first opening up our coding environment. And so that's going to be this. And the way you get to this is you search for this, Python Online Compiler, and you click on the programmers, I don't know how to pronounce that, programmese, search result. And you should see something that looks like this. Actually, what you might see will probably look something like this. And then you'll be able to click on dark mode right here with the little moon, and then click this little full screen thing, and that kind of just makes it bigger. So, at first, it may look like this, and then you can switch it to look like this. So I will also put the link here to where we are in. Oh yeah, so I should mention. So even though I am doing this with JJ, I'm really doing it with you, all of you on the stream as well. So if you have any questions, just assume that I'm here to teach you and answer your questions as well. So if you have questions, just ask in the chat. I'm keeping track of the chat and will answer anything that might come up. So this isn't just for you, JJ. This is for everyone.
Excellent.
But first, I wanted to talk a bit about what we're going to be learning specifically. So the thing is that coding is a huge topic, and there's tons to learn. Like, I've been coding for 30 years, and I'm constantly learning new things. There isn't really a way for us to do everything for how to code in like 3 hours. But what I want to give you is enough understanding of the basics that you have a pretty solid standing, so that if you run into code in the future, you could at least look at it and go, oh yeah, I kind of get what's going on there. Maybe it's not like, oh, here's a page of C code, and you're like, yeah, I know what that does. It's like, No, it's just like, okay, yeah, I kind of get what's happening here.
Yeah.
And you're not totally lost if, you run into things, or if you wanted to Google and find new things, you could do that.
Okay.
So with that said, let's start with the just the absolute basics, which is we'll go back to coding here. And again, if you're just tuning in, this is where we are. Search for Python Online Compiler and click the program is search result. It's usually like the first or second result, and you'll end up here. First off, let's talk about numbers. Okay, so computers, one of the types of information they can store is numbers, and usually it separates numbers into two types of numbers. That's integers, which are whole numbers, and another kind of number that just has decimals. Now, in coding, a lot of times, I'm going to switch this over here for a sec. So we'll have numbers that are integers like 8 and 7 and 6, 5 and -3 and 48. These are all integers, and oftentimes these are shortened to int in programming because it's short for integer. Then you have numbers that have decimal points, like 48.3 and 3.7921 and 5.6. Even whole numbers like 7.0. Those are also not integers the way a computer thinks it, because it has a decimal point. And these types of numbers are called floats. Okay? Now, there's a big technical reason why they're called floats.
Okay.
And it would probably be a big old long discussion of just to explain why they're called floats. So I'm not going to get into why they're called floats, except the fact that for you should just know that if it has a decimal point, think of it as a float. If it doesn't, it's an integer. Okay? So we have integers and floats. And these are two kinds of numbers that computers tend to work with. And so right now we're going to do a few things with just numbers to get some understanding of how these work and what they do. And again, this is pretty simple, so it'll go pretty quickly through what we're doing here. All right, so over to our coding environment. We're going to use, so the way we have certain things called functions that allow us to tell the computer to just do something. It's kind of like an instruction, tells, hey, do this thing. And we're going to get into what that means and how to do that. But there's one that you just should know right off the bat, and it's called print. Okay. And the way you do it is you type print, parenthesis, and then what you want to print goes in the parentheses. So for instance, let's just put in a number like 56 or whatever you want. So you put print, parenthesis, 56, and then just hit run. And you'll see it just prints 56. It just does that because that function print. Now we can put in other stuff here too. We can say like 56 plus 79, run, and it just runs it. So this is pretty basic, but I want you to understand what's happening here because it's important.
Yeah.
So we have print, parenthesis, 56 plus 79. When it goes to run this command, it's not printing 56 plus 79. It's doing the math here and then printing the result.
Okay.
And that's important. So what happens is in the computer, this happens like this. It does the math of 56 plus 79 and turns it into 135, and then it prints 135. Yeah. So it's kind of like two steps, even though we see it as one step. And so you can add in lots of things in there. Like you could say 56 plus 79 times 3. Or let's just do something really simple so it's like easier to track in our head, like 3 plus 7 times 2. Now, if you remember the way that math works, you would do this first, 7 times 2 first, and then whatever that is, add 3. So if we run this, you'll see it does that. It does 7 times 2, which is 14, and then adds 3. You can force it to do a different order, just like in math, where if you put parentheses around things, like you could put parentheses around 3 plus 7, and now that tells it, hey, do this first, then multiply by 2. So you can see we're just changing it here and then click run and then you see the result. Okay, you see how that worked?
Yeah.
So you can put in as complex of a math problem as you want in here, and it will just do it the way you would do it on paper, and then whatever the result is, it just prints it out. And that's important, that order of operations, if you remember from math class. Order of operations is how that works. And that's true of all the different things you can do as like basic arithmetic. And I want to show you what those are. So we're gonna do a bunch of math problems here. They're all basic arithmetic. So we'll do like 4 plus 3, and then we're gonna do 4 minus 3. Then we're gonna do 4 times 3, and then we'll do 4 divided by 3. And this is how you do each of those arithmetic operations. So we have plus, minus, this is the asterisk, shift 8, and that will do multiplication. And then a forward slash does division. If we hit run, you'll see it gives us all of those answers.
Nice.
And again, you can combine these in lots of different ways. So so that work for you?
Yes.
Okay, good. All right, great. So now what we're going to do is we are going to add 2 more things that we want for doing basic math. So for example, if I do print 9 divided by 4, and we get the answer, it's 2.25, okay?
Yeah.
Do you remember when you were doing math class as a kid, and when you first learned division, you do it with remainders?
Yes.
Like, this remainder that, so 9 divided by 4 would be 2 remainder 1, right? So 4 goes into 9 2 times with a remainder of 1. In coding, there is a way to get the remainder. And the way we do that is we do the percent sign instead of a slash. And if you kind of notice, it actually looks kind of like a division symbol because it's got that slash through it. But if you do that operation where you get the remainder, that's called modulus. Okay? I'll type it here, modulus. And it gets shortened down in coding to mod. So you would say, the way you would read this would be 9 mod 4. Like that's how you would read that.
Okay.
Whereas this would be, 9 divided by 4. Okay? And if you run this, you'll see, hey, look, we got 1. So we got 9.
Nice.
Mod 4 is, goes in 2 times in remainder of 1, and we want the 1. So this is really useful in, we'll see why later, but it's just a thing we can do. The other thing we need to do is be able to do, well, what if we want to do division where we only want a whole number as the result?
Okay.
Okay, so in this case, if we did 9 divided by 4, you saw we got, 2.25, but we just want 2. So you can do a double slash, and that tells it, I just want integers. Get the idea?
Yeah.
Yeah, and that's useful sometimes when you just, because like if you're trying to figure out, because integers are really useful because like when you're dealing with things like an email, right?
Yeah.
You didn't read 3.5 emails.
No.
You read 3 emails, or if you're trying to figure out like, well, how many people can go to the movies? And I've got $30. Okay, well, price of the movie divided by 30. Well, it's not 3.2 people can go to the movie, or, 1 point, it's 2 or 3. So sometimes you need to do integer math.
Okay.
Does that make sense?
Yeah, it does.
Okay, good. So these right here, plus, minus, times, division, mod, and integer division, are the ways we can mess with numbers.
Okay.
Does that make sense?
Mm-hmm.
Okay, good. So now sometimes we want to deal with information that's not numbers. We want to deal with text. And the way, I'm going to just erase all of this here and hit clear. So sometimes we want to deal with text. And the way we deal with text in coding is we use quotation marks. So we do hello, and then if we run it, you'll just see it prints hello, but it prints the characters hello. If I took out the quotation marks, we'd actually get an error. Because, and you don't have to worry about what the error is, but you can just see, oh, we get an error, right? Yeah. So you have to make sure you put the quotation marks around it so it tells the computer, this is text I want to print.
Got it.
And so the quotation marks are pretty important. Now, sometimes though, you'll see we're using quotation marks, and you can put long stuff in there, like you can say, this is my first time coding, right?
Yeah.
And then we run it, and it just prints the whole thing. But sometimes you want to put something in there that needs a quotation mark.
Oh.
Yeah. So like, for instance, if we said, my name is, and then we put Dylan, quote, and I like dogs. Okay, so now, if we try to run this, we get a problem. We get an error.
Yeah.
Now, again, you don't have to worry about what the error is. You can just see, oh, we have an error. So we need a way to use quotation marks without telling the computer, hey, we're done.
Yeah.
So in that case, we use a slash, like this, before the quotation mark. And that tells the computer, like, hold up, don't end off the text. Just use the next character here, and I actually want to print a quotation mark.
Okay.
And you actually notice it even puts it in a different color here.
Oh, there we go.
Does that make sense?
Yeah.
And then if you try to run it, now it works fine. There is another way to do it too, which is you can, let's say we use quotation marks, you can actually put single quotes around the whole text like this, you see? And because we started it with single quotes, it knows, oh, double quotes isn't ending it.
Oh, interesting.
Yeah. So that's another way of doing it. But sometimes that doesn't work either because my name is Dylan and I'm happy. Okay. So Indie Cluster had a question. Is that backslash specific to Python? No. A lot of programming languages have that ability where you can use a backslash and then put something else and it will treat it a little bit differently. And oh, that reminds me, this is something I wanted to point out, that a lot of the concepts we're going to go over today are not specific to Python. And I'll try to point out things that are just generally programming specific as opposed to Python specific. And all the concepts we're going to learn today as concepts are concepts that work in almost any programming language. And a lot of times how they work might be a little bit different, but the fact that they work like that is pretty much the same in a lot of programming languages. So even if, you know, slash quote, maybe that's how Python deals with quotes inside text. If you think about what the concept is, oh, I need a way to print quotes inside of another quoted thing, that's a thing that other languages would do. And so sometimes you might need to look up, oh, how does that language do it? But you can at least know there's got to be a way to do this. Okay, so you see here we have a problem where we have, you know, single quotes, but then we need to use a single quote and then it creates a problem. So that's why it's handy to have the backslash. Now we can also do, there's another backslash thing we can do, which is we can do this. So it is a nice, and then /n day today. So try that. And I want you to run it and see what happens. So we're not even putting spaces in them. We're just saying nice /n day today. Now you notice the /n is in a different color. So it's just paying attention to the n. It doesn't care about the d that's butt up right against it. And we run it, and what it put instead of the /n?
A space?
Yeah, space to a next line. So that's a way to tell it, hey, this is a new line right here. Right here, I want a new line.
Yeah.
But I'm writing it all in my code as one line, but I'm using that slash thing as a way to stick in a new line right in the middle of my code. Okay. Any questions on that so far?
Nope.
Good. Now, these things where you have stuff in quotes, those are called strings. And the reason they're called strings is because you can think of it as like characters strung together. Like when you're a kid, you ever make like the bracelets with like the beads with the letters all, it's kind of like that. They're all strung together. And
So you said these were strings, the 1, 2, and 3? Print, and print?
the parts in quotes.
Oh, got it.
That information that's in quotes. And now, as opposed to, for example, so for example, look at this. Let's say if I print 45, okay? So let's run that. Okay, that kind of looks like the same as when we just did print 45, right? Not much different.
Yeah.
Okay, but what if I did this? Print 45 plus 10. And then underneath it, I'll do it without quotes. Oops, 45 plus 10. Okay, so now I want you to see the difference here. So if I run it, I'm actually going to get rid of all this stuff just so we can focus on what we're working on. So if I run this, aha, that did something different.
Oh, yeah.
Because when it has the quotes around it, it's actually saying print a 4 character, print a 5 character, print a space, print a plus, print a space, print a 1. And so it's actually telling it print these characters, like as if they're characters all strung together.
Yeah.
It's treating it like text. Whereas here, there are no quotes around it, so it's thinking of, oh, this is a number, and this is a plus sign to do something with the number, and this is another number. So it's actually treating it totally different. But with the quotes around it, it actually treats it like text.
Yeah.
And it does exactly what you type. So if I forgot a space here, it's just going to do exactly what I put inside the quotes.
Oh, wow.
Whereas if I put a space here, it doesn't really care,
Yeah.
It doesn't change it at all. Does that concept make sense?
Yeah.
Okay, good. So this is important. So so far, we've talked about a few different things. We've talked about integers, floats, and strings.
Yeah.
Integers, whole numbers. Floats are any numbers that has a decimal point. And strings, which are just characters strung together, and they're surrounded by quote marks.
Yeah.
Okay? Now, there's one more kind of thing that we are going to talk about. Actually, before we do that, I want to talk about one more thing, which is, so you saw how we did things like plus and minus and division and stuff like that with numbers. There are some things we can do like that with strings. And I want you to see what happens. So if we do print hello plus Dylan. So you notice this plus is not inside quotes.
Yeah.
So this is one string, and this is another string.
Yeah.
Does that concept make sense?
Yeah.
So this string plus this string, what do you think will be the result?
It's gonna try to add.
Try it.
hello
Let's
and Dylan.
let's run it.
Yeah,
Let's run it and see. So we'll run it.
Hello, Dylan.
It just took the two strings and stuck them together.
Nice.
Yeah. And do you notice it didn't put a space between them, right?
Yeah.
Did I tell it to? Did any of these strings have a space?
No, it didn't.
No. So it just takes it and it treats it as if like, oh, we're gonna turn this into one string. Now, yeah, go ahead.
So what if you put a space before the D on Dylan?
Let's try it. Now it prints literally exactly what I put. HELLO space DYLAN. Now, I want you to notice something though, that the computer, again, remember, does these in multiple steps. So if this quote, or if these quotes and the plus symbol are here, then it does all the work first. So it does hello plus Dylan and actually does the plus and then puts it all together and then it prints the result.
Yeah.
Okay? Now, I want you to think about something else. So if I'm going to switch over to drawing here for a second because, let me clear this off. Because I want you to notice an idea. If we did 3 times 2, what is that? What's that equal to?
6.
6, okay? Let me make sure. Yeah, okay, just make sure I'm on the right screen here. So if I do 3 times 2 and we get 6, what's actually happening here with the 2? When we do 3 times 2?
2 is going 3 times.
That's right. We're saying 2 plus 2 plus 2. So we're saying, or actually, I mean, the way it's written here, 3 times 2. it's really more like 3
plus 3.
plus 3. Yes, that's exactly correct. Yeah. So really what's happening is it's saying do 3 2 times.
Yeah.
Okay? But you notice we could think of it the other direction. We could say 2 times 3, and that works the same, right?
Yeah.
But in this case, we have 3 times 2, and the actual math of what's happening is 3 plus 3. Now, if we did, oops. Uh-oh, what did I just get rid of?
You're good.
Oh, okay. Just want to make sure. Uh-oh, hold on one second. Give me 1 sec. I accidentally closed something here. My bad. Okay. Sorry. So now let's think of something else. Like, let's say we had hello. Now, what if we did something like this? Hello plus hello plus hello. Now, if we thought of this, now what if we thought of this as, you know, something we're multiplying, right?
Yeah.
This would kind of look like this. Hello times 3.
Yeah.
Right?
Yeah.
Because effectively that's what's happening.
Yeah.
So if we look at, let me go back to, I'm just going to make sure, I accidentally closed something, so I want to make sure that this works. Yep, there we go. Okay, so if we go back to our code here, and we try to run that, Will is dying. He's like, what is 2 times 3? Okay, so if we go back here and we try print hello times 3, we get exactly what we'd expect.
Hello.
Hello, hello, hello. Okay. But let's try it the other way. What if we did, since, you know, you can do 2 times 3 or 3 times 2, couldn't we do 3 times hello? And that does not work. Well, actually it does. Oh, wow. Okay, so this is my bad. So it figured out correctly that it should work. There are other programming languages where you can't do that because it's like the same as saying, you know, 3 times lawnmower. It doesn't work. It goes, okay.
Like,
but
no.
so kudos to Python for figuring that out and knowing the difference. There are some programming languages, if you do it in the reverse order, it gives you an error. Hey, see, I learned something today too. This is good. Anyway, so you see we can do plus if we want to add things together. So like if we did this plus Dylan, right? And 3 times hello will give us hello. So we can do plus in division. So I just wanted you to know that like there are ways to do stuff with strings besides just printing them out.
Nice.
Okay?
Okay.
Okay, so now I want to talk about something else. And this is a concept of true and false. And you always hear that computers think with ones and zeros, right?
Yeah.
Which is true, you know? But there's a concept of 0 being false and 1 being true in a computer where it can do logic with true and false. And it can think about the concept of true and false in your program, you know? And this happens all the time. Like, you have things like, if you're trying to log in, is their password the same as the one that is on file? Is that true or false? You know?
Yeah.
Are they trying to load a movie that doesn't exist? True or false? You know? Did the player press the jump button? True or false? You know, like there's a concept of true and false that happens all the time in computers. And the way that that concept is dealt with in coding, they give it a name, and it's called a Boolean. And the reason they give it a name Boolean is because there was a guy named with the last name of Boole who lived a whole long time ago that learned a whole lot of math about how to do math just with true and false. And he came up with all these cool concepts for how to do stuff and logic with true and false. So now we name true and false on the computer after that guy. And the way we do that is I want to show you. So if we do print, and we can just say print true. And you notice like it turns it into a different color, which means the computer actually knows what that means. And if we run it, it's just going to print true. It looks like it printed the string true. It kind of looks like that.
Yeah.
But it didn't. It actually printed this concept true.
Yeah.
You know? And you can do the same thing with false, right? And notice in Python you have to capitalize it. In some programming languages you don't capitalize it, but there's still this.
Noticed that, yeah.
Yeah. But there's still this concept of true and false. Now we can use other things to represent true and false. Like for example, if I said 5 is less than 4, is that true or false?
False.
Good. So remember how I told you the computer works out all the problems before it prints it?
Yeah.
So if 5 is less than 3, is that true or false? False. So what will get printed? False.
Oh.
Right. Now if I switch it around and I did print 5 is more than 3, that turns into true, right?
Yes.
So then the computer will print true.
Oh.
Okay. Now what are some other ones you could think of besides less than or greater than?
That are false? JJ is a billionaire. It's false.
Okay. That'd be hard to write in code.
No, would.
Yeah.
Let's see. Like 10 is greater than 1.
10 is greater than 1.
It'll say
And we'll get true, right? And if we switch it around, less than, we get false. Now there's other ones we can do here too, which is, and they're really useful in programming, which is we have greater than or equal to, or sorry, less than or equal to.
Okay.
Okay, so in this case, is 5 less than or equal to 3?
No. So it'll
No,
still say
it's
false.
still false. But if we said, is 5 less than or equal to 5?
Oh,
You know,
it'll say
that would end up being true.
nice.
You know, you can also do the opposite. You can say greater than. Is 5 greater than or equal to true? You know, so we could say is 10 greater than, or 105, 10 greater than or equal to true? So these are other ways we can write that.
Nice.
Then there is one other, or two other ones, which is equals equals. And you'll understand why we're using equals equals, but when you're comparing things on the computer, we use equals equals.
Okay.
Because equals has a whole nother meaning when we're coding.
Okay.
But equals equals is when you're comparing things to see, are these the same? So is 10 equal to 5? Is it equal to 5? No. Now what about 10? Yes. Okay. And that may seem like, okay, that's pretty obvious. But what if you did something like this? 4 plus 6. You see how this can be a little more complex?
Yeah.
Because which part of this is it going to do first?
The 4 plus 6.
That's right, because it's in parentheses. And so it's going to do 4 plus 6, and that's going to turn into 10. Then it's going to look, hey, is 10 equal to 10? And then it's going to say, yes, that's true. And that's what it'll end up printing.
Okay.
But you see how it goes through those steps in order to figure that out. And it kind of needs to do all that because it's got to do all the math before it can decide what to print.
Okay.
Does that make sense?
Yeah.
Okay, good. There's one last one, which is not equals. And you write it like this.
Oh, nice.
Exclamation point equals, which means not equals. It's the opposite of equals. You know, so in this case, would this be true or false?
False.
That's right, because 4 plus 6 would turn into 10. And then is 10 not equal to 10? No, 10 is 10, so that's false. You get this concept, true, false?
Yes.
Okay, good. And you can compare things. I don't remember if Python does that. Let me see. So Will had a question, can you do this? Nope, it doesn't like that one. In some programming languages, though, that may work.
And
Different
that
programming
means
languages.
Equals?
Well, no, he was talking about not equals.
Oh.
Different programming languages have different ways to write not equals.
Okay.
Like some programming languages write it with a tilde like that, and that's how they say not equals. And some use exclamation point equals. So you might have to look it up if you're learning another language. Hey, how do they do not equals? But there's that concept of not equals, which is pretty common. You can also compare other things too. Like, for example, let's say we compare Dylan equals JJ. False.
False.
Good. Dylan not equals JJ. True. You see how that works?
Yeah.
Yeah. Okay, so that's this concept of true and false, and it's called, that type of information is called a Boolean, okay? So we have 3 types of information so far, or sorry, 4 types. We have integers, we have floats, we have strings, and Boolean is often shortened to bool, because programmers are lazy and we like to shorten things. So we have int, float, string, and bool.
Okay.
These 4 concepts, you can do like pretty much anything with those 4 concepts of stuff.
Wow.
And almost everything that you'll deal with is just some combination of these. Like sometimes they get a little more complex because they combine them in different ways. But really when it comes down to it, it's just these basic types of information. Like for example, like in other programming languages, like computers can store up a certain number of integers, just because computers can't count to infinity, so they can count up to a certain number. And some computers, an integer can only go up to be like a certain size number.
Yeah.
But then they might have other types of integers that can store even more numbers, and then other types of integers that can store even more, and then there's other types that are very, very precise about how it stores decimal points, and but basically it's whole numbers, decimal point numbers, strings, and Boolean, like true, false.
Nice.
Does that make sense, these concepts so far? You tracking?
Mm-hmm.
Okay, good. I'm going to take a drink real quick. If you're watching, you should take a drink too. Stay hydrated. JJ got me this water bottle, by the way. This is a really slick C3PO water bottle. You should see his. Show
I got
show
the
him
Darth
yours.
Vader one.
Yes, these are really nice. Yes, water helps coding. I'm water cooled.
Nice.
Actually, these, believe it or not, these things insulate extremely well.
Yeah.
Like I filled it up one day and I came back the next day and it was still cold. I was like, dang. Okay, so that was a lot to take in at the start, but those are just types of information that computer can deal with.
Yes.
Now we're going to work with what do we do with those, and how do we, play around with them? Because obviously typing in all the numbers and typing in all the stuff is like, that's tough. You wouldn't be able to write a whole giant program with just writing in raw numbers.
Yeah.
So we need a way to store information so we can deal with it and change it later.
All right.
And this is, we're going to deal with a concept called variables. So have you ever heard of variables?
Yeah.
Do you have an idea like what it means for you or anything at all?
Not really in coding.
Okay, so when you learn about it in math, usually it's just like it represents some number where you don't know what it is, And so I'm going to switch over to my thing here. So a lot of times for variables, like in math, you might have like x equals 3 plus 5, Okay, well then x is going to be equal to 8. Or you could see something like 8 equals x plus 5. And you can figure out, okay, this means 3, because 3 plus 5 is going to equal 8. You get the idea?
Yeah.
So in the case of regular math, x just represents, as a variable, some number that we don't know what it is. The reason they're called variables is because they can change. They can vary.
Yeah.
It's a variable because it can vary. We are going to deal with variables in coding as ways to store information that can change over time. Okay. So the kinds of information that a variable can store are those kinds of information we just talked about. Ints and floats and strings and bools. Okay. So for example, if I say x equals 5, this means this is a variable. X is a variable, is a name of a variable. But here's the deal. In math, we learned that equal sign means these two are the same. That's not what the equal sign means in coding.
Okay.
And it's really important to know that, because this is something that can trip so many people up, is thinking that the equal sign means these are equal to each other. And that's because it's not what it means. In coding, the equal sign means take what's on the right side and put it into the left side. And that's important to understand that concept.
Okay.
It's 2 steps. You have what's over here, and then you're taking it and putting it over here.
Okay.
Okay, it's like an action, actually.
Yeah.
All right. So, for example, if I say, and you can actually write out this code, x equals 3 plus 5. Okay.
X equals 3 plus 5. Okay.
So what this does is, remember how I told you about how the computer does each of the steps individually before like finishing, like each line of code, it does all the steps needed?
Yeah.
So in this case, when we have this line of code, what it actually does is it does everything on the right side first. So in this case, what would it turn 3 plus 5 into?
8.
Exactly. So then to the computer, this line of code would turn into this. Now, what's it going to do with the 8? It's going to
put it
put
on
it
the left.
into x.
Okay.
Okay. Does that make sense?
Yeah.
Now, if we do,
I typed it in, but it gave me an error.
okay, good. Let's see why. But I want you to get this concept. Like it does this work first,
Okay.
and then puts it over here.
Yes.
So
okay,
if we
got
did
it.
something more complex, like if we did, x, times 7 plus 3, and we do like parentheses like this, it's going to do all of this
Those
work
steps before
it puts the answer over here.
Okay.
But this equal sign means take all this stuff and put it over in here. Okay?
All right.
So let's go back to our coding here and see how this is gonna work now. All right. So let's do that. We'll do x equals 3 plus 5.
Oh, without the print.
Yes, without the print. That's correct. We're not using print in this case. So it's just x equals 3 plus 5. Now, if we run this, nothing happens. Well, actually, something did happen, but we didn't tell it to show us anything. We didn't tell it to print anything.
Okay.
So it did the work, but it's like, okay, I'm done.
Nice.
It actually just we haven't told it to do it. But what we can do is we can say, okay, after you put 3 plus 5 in x, print x.
Oh.
You get that concept?
Yes.
Yeah.
What? Why is it not working for me, but it's working for you?
Sure, well, what error are you getting?
Let's see. X is not defined.
Okay, do you have x equals...
Oh, I have capital X.
Ah, okay, good. That makes a difference. Capitals versus lowercase actually does make a difference in coding, because the computer sees the letter X as a capital and the letter X as a lowercase as actually different characters.
There it is. Yeah.
Okay, good. Now, in Python, generally, we write all variable names using lowercase.
Okay.
So when you're making variables for your program, you're going to use lowercase to make them.
Okay.
And so now we get 8. You can make this as complex as you want, just like I said before. You could do, times 7 plus 3, and it just does all the work,
Yeah.
and then runs it,
Nice.
And again, it's doing all of this work and then sticking it in here.
Yeah.
Now I want you to see something. Let's say we print x, but now we're going to do print x plus 5. Okay? So what's going to print out?
Whatever the X is plus the 5.
That's right. So it's first going to print 53, then it'll print...
Yeah, plus 5.
Exactly. So let's run it. There it is. Print 53,
Boom.
then 58. Now remember, it's doing this work and then printing the result.
So it's doing the top one, right?
Yep.
And then turning into the X, and then it's doing that one.
That's right.
Yeah.
Now here's the deal. What do you think will print now if I do print x? Just what's your guess?
58. It's just gonna... Sorry, 53.
Why will it print 53 on the second time and not 58?
Because you did X equals, so it's...
That's right. This is something that's important to recognize. We didn't change what's in x here by adding 5. We just said print whatever x is plus 5.
Yeah.
Kind of like if I said, how old are you? And you tell me, and then I say, okay, how old will you be in 5 years? I didn't just make you older.
Yeah.
I just said, tell
told
me
you.
how old you are and 5 years.
Yeah.
Your age still stays the same.
Nice.
Yeah. So in this case, the same thing. We're just saying, well, tell me what x is if you add 5. And then x is still going to hold what it held.
Yeah, there it is.
Okay, good. All right, does that concept make sense?
Yeah.
Okay, good. Now, if let's say we do this, print x, but then let's say x equals x plus 5. Now, that's a little bit of a tricky piece of code to look at. But I want you to remember that it does this in steps. So if we have x equals x plus 5, what's the first step it's going to do? Remember, it does the right side first.
Yeah.
So what does x equal at this point?
At that point, it's 53.
Good. So then what is 53 plus 5?
58.
So then this turns into
58.
58.
So,
and then it puts it back into x.
So you changed it.
Exactly.
Oh, wow.
So we're actually saying x equals whatever x was plus 5
Got it.
is what now x will be. Now, if in the chat, I want you to tell me if this concept doesn't make sense, because this can be something that can trip people up. So if you're looking at that going, oh, I still don't get it, please say something. But this concept is really helpful. We can take the value of x, do something to it, and then put it back into x again. And you'll see how we'll use this a lot. But this concept is really helpful. But you have to notice that it's doing this side first, getting the final result, and then putting it in x. But you can see here we are actually changing x. So then now when we print x, we are actually printing two different numbers, because this was 53 and now it's 58. And again, this goes back to why it's called a variable, because it can vary.
Yeah.
You know?
Cool.
Would you be able to define the variable in the print function? No, you can't, because defining the variable is its own action, and it's its own thing that's happening, whereas printing is its own thing that's happening. So in this case, you would define it first, and then you can use it in the print function. I hope that makes sense. So in fact, that's actually one of the things JJ ran into when I was first explaining variables, and we were talking about just x equals 3 plus 5. Originally, he had print this, and it was giving him an error. So we went to run it, and it said, whoa, it goes, what are you doing? You're trying to do a whole thing inside a print. And it's like, nope, don't like that. So then we have to do this. So we have to define x first, and then we can use it.
Boom.
Okay, good. Any questions so far in that on variables?
No.
Good.
Got it.
So now in this case, what kind of information are we storing in x? Remember, we had those different types of information.
Integers?
That's right. So in this case, x is storing an integer. Now, we could store a string in there too. We could say x equals Dylan.
Ooh, nice.
Yeah. So now when we print it, it just prints Dylan, because that's what's being stored in there.
Okay.
It doesn't care that it used to store 8. We're just storing something new there.
Okay, cool.
Okay? Now, this is where we will have a problem, though. So let's start off some new thing, and let's make a variable called name. And we're going to say name equals, and I'm going to set it to my name, but you can set it to your name. And we're going to say, I don't know, what should we do? Something with a number. Games. We'll say 500 games.
Okay. And Dylan, is there a particular reason why you go 2 spaces down instead of 1?
Nope.
Okay.
Those spaces, I'm just doing that so that it's easier to read on the screen, but that's a good question, because it doesn't actually matter. It doesn't care if they're spaced like this or like this.
Okay.
Now I want to print out Dylan has 500 games.
Okay.
Okay. So if I do print name, I can do plus has, and here's where we went into a problem. If I do plus games, okay, so notice, first of all, notice the different colors here. This means we're talking about the variable. And then we're adding this string. But then we're adding something here. We're adding an integer to a string.
Wait, say that again?
Yeah, we're trying to add an integer to a string because this has the number 500.
Yeah.
It would work if we did 500 like this, because now we're adding another string to another string, right? But this is a problem. We have a number that we're trying to add into this string.
Yes.
And if we try to run it, it goes, what are you trying to do? You're trying to stick together integers and strings, and I know, right? So we have to tell it, we can put a function around this called int. And this actually gives us I meant not int, string, str. My bad. This says, take what you have inside the parentheses and give me a string version of it. So let me know if you run into a problem there.
Let me see. What did I do wrong?
There is a lot of like back and forth in terms of the quotes and not quotes and stuff like that. So we're doing name plus quote.
Nope. Oh.
Do you find it?
There we go. JJ has 500 games.
Good.
Oh, but I didn't add the spaces.
Ah, okay, good. Yeah, see, notice I have a space around the has and I have a space before games. And if you don't do that, it literally will print exactly what you tell it to print.
Oh, wow.
So you have to make sure you put those in there. Okay, so now in the topic of running into errors, I want to talk about one thing here, because this is something that's often very frustrating for people learning how to program, which is that a lot of times people will make little mistakes in their code, like they forget a quotation mark or add a space in the wrong spot, or the equal sign is not the right thing, or something like that, and they'll get an error, and then they fix it, and then they get another error, and then they fix it and they get another error. That's normal.
Yeah.
Running into those kind of errors is totally normal in coding. People who have been coding for decades run into those same kind of errors. Just like little errors where, you've been writing a bunch of code and then you go to run it and it totally fails, and it's some really dumb thing that's hard to track down, and you fix it and you run it and then it's broken again, and you fix it and you broken it. And like, that's not specific to, I don't know how to code. That's specific to you are coding.
It's almost like a puzzle.
Yes. Yeah, exactly. It's like, not everything's going to be perfect, exact every time you write it, unless it's like super simple, and you know what I mean? An easy example for me is I spent half an hour trying to figure out this problem with my code, and I was writing a game in the Unity game engine, and everything should have worked and nothing was working, and I searched through my code, I was asking friends online, I was searching Google, I was like tearing my hair trying to figure out what it was. It turned out I had an uppercase S where I needed a lowercase s, and that was what was breaking it.
Pulled the JJ move.
I mean, it's totally normal to like have that. And I've been coding for decades, literally decades. Yeah. So don't worry about if you run into problems like that, because it's normal.
Okay.
Yeah. You figure it out, you find the next error, you do it, and you might run into 10 of those before it finally works. Okay, good. So you get this concept. We have variables here, and sometimes we have different types of variables that we need to connect together, add them together. And okay, good. We can go the other way too. So for example, let's say we have games, and we have another variable called new games is 5, and I want to print how many games total. Sorry, let's say I'm going to put this into quotes. Okay. So I want to print games plus new games. Now, games is in quotes. So what kind of information is that if it's in quotes?
It's a string.
That's right. So games is a string. Now, what kind of information is new games?
Integer.
That's right. So a string plus an integer, not going to work. I want a number at the end. I want this to be a number, not a string of numerals, Yeah. I want it to be a number, and I want to be able to do math on it. And so I need to turn this into a number. So remember how we use the string function around that? We can use the int function around this So you notice I put int and then parenthesis in games in there. Now it takes what I had in there and says, well, give me that as an integer. Give me quote 500 as an integer. And if we run it, you'll see it prints the actual number. And it can do math on it. Because it's giving me the number version of it.
Yeah, okay.
Now again, we didn't change the variable. We didn't change it. We just said, give me the integer version of the variable.
Yeah, makes sense. And
it's like, if I said, give me your age in Roman numerals, you give me the Roman numeral version of it, Yeah.
And then you add, I got it.
Okay? Okay, good. So that's just a useful thing is we're going to be able to, change around these variables.
Okay.
Now, variables, you've seen we're storing variables as strings and numbers, We can also store true and false. Okay? So, for example, we can say is alive equals, 10 greater than 4, Now, 10 greater than 4, is that true or false?
True.
Right. So the value true gets stored in this variable is alive. And if we were to print that, print is alive, it prints true.
True.
Because that's what it's holding. Okay?
Yeah.
And we can even make this, a little more interesting. I'm just gonna put this up here. Let's say health equals 7, right? And we can say is health greater than 0. Well, that's is alive, right?
Yeah.
So is alive is based on whether health is greater than 0.
True.
Now, what if health is at -2? Is alive? False. You see?
Yeah.
So this is how we can kind of combine these, is we can have it do this work first, figure out an answer, and store the answer here.
Yeah.
Now, again, remember, it's doing this side of the variable first. It's figuring out health greater than 0, figuring it out, and then storing it.
Okay.
Okay, any questions on that?
No.
Okay, good. So we have a lot of stuff that we've gone over so far. We've gone over different types of information, okay? And I'm actually going to switch over here so I can just summarize this pretty quick here. So these are some of the things we've gone over so far. We have the types of information we have are
integers.
Int. We have float, which are decimals, right? Better. I'll leave it. Okay. Float. We have string, and we have bool. Okay, and these are examples like 8 and 8.2 and 8, right? And false, or it could be true. Okay, so we have these types of information. We have the ability to do plus, minus, times, divide. We also have modulus, which is remainder, right? This is remainder division. Okay, and we have, this is integer division. Remember, this will give us the integer version, even if it's like a partial, like 2.5, will give us 2.
Okay.
Right? And then we also have, for comparing things, we have equals equals. We have not equals. We have greater than. We have less than. We have greater than or equal to. We have less than or equal to, right? These are all things we can use to compare things. All right?
Yeah.
And then we have different ways of turning things into something else. We also have, we can store variables. Like we can say, x equals, 3 plus 5. Okay?
Yeah.
Or name equals Dylan. Right?
Yeah.
Okay. All right. So we've gone over a lot of stuff. What we're going to go over next, we're going to take a break. We're going to take about a 5-minute break so everybody can, go to the bathroom, get a drink, all that kind of stuff. And then what we're going to do is we're going to go over the next thing, which is how we can get information from the user. So right now we've been typing all the information, all the variables, all the value of all the variables into the computer,
Yeah.
which is useful, but you're obviously not going to know all the information before you start a program.
Yeah.
You know, sometimes you want to ask the person, hey, what's your favorite number? You know, and then do something like that. You can't know that beforehand. So we're going to figure out how to ask the user for information and then be able to do stuff with that.
Cool.
And because we can now have information from the user that we don't know about, we're going to have to ask questions about that information, right? And we have to make our program make decisions about the information that we have in our program.
Okay.
Okay, so we're going to learn about decision making as well. Okay?
Sweet.
Okay, so we're going to take a 5-minute break. We'll be back at 2:05 and we will keep going. All right, so give me 1 second. I'm going to go over here. I'm going to put back at 2:05 p.m. Okay. All right. We will see you in a minute. Okay, we are back. Can everybody hear us okay? Just want to make sure that we are actually back. Okay, good. Excellent. Okay, so we learned a lot of stuff before the break. So now let's start learning how to use it. So what we're going to do is we are going to learn how to get input from the user and do stuff with it. And so let's just do some really simple stuff to start off. And let's make a variable called name. And we're going to say it's equal to input parenthesis, quote, what is your name? Question mark. And then I'm going to put a space after the question mark. I just want you to note that I'm putting a space because it puts this right before the blinking cursor where it lets them type. And if you don't put a space, the blinking cursor is right at the end of the question mark. And it looks funny. So then we're just going to print whatever name they write in. Okay? So let's run it. What is your name? And then you can go over here on this side and you can just type it in. I'm going to type Dylan. Obviously, you don't have to type Dylan. You can type your name. Oh. Whoa, what happened there? Hold on one sec. Let me run that. Hold on. What is going on? That was weird. Hold on. I'm going to reload my thing here because I think it got a little bit confused. Name equals input. Oops. Input. What is your name? Oops. Print name. Sorry, this should be working. I'm not sure why it's not. Hello? Alright, so I'm not sure what's happening here. This should be working. Let me try this. Sorry. Yeah, that's weird. I'm not sure what's going on. It should work fine, and it's not. Okay, that's working. All right, so we're going to deal with that later. I'm not going to try to mess with it. The point is that input will get input. Maybe it's not liking having something in here. Hello? Let's try that. No, that works. Okay, fine, whatever. Either way, all right. Yeah, welcome to programming. That's what Will says. It is absolutely true. What is your name? We're gonna hit run. What is your name? Dylan. And see, now it's not working. It doesn't like asking what my name is. Yeah, it really hates that. Okay, fine. I'm not gonna ask it what your name is. What if we try this? Name. Let's just see. Dylan. Nope, doesn't like that. Okay, what if we just do name colon? Maybe there's something. Nope, it really does not like it. Sorry, yeah, Will's comment is exactly right. Welcome to programming. Who knows? I'm just gonna write this. Oops. Does it work for you, JJ?
I don't know what it's supposed to be doing.
Remove the space after the first line.
Oh, the space after first line? Yeah, it's working.
Remove the space after the first line. Space between the two lines. Oh, okay, so like this. Nope. Still doesn't like it for me. That is bizarre. Well, I'm going to take out this here. We'll run that and see. Oops. Okay, well, fine. All right. Yeah, it doesn't matter if I put like name like this and run it. It was still giving me a problem. Yeah, see? Okay, so fine, whatever. I'm not going to deal with that. I'm just going to run with the fact that we're not going to have it ask you. So we're just going to do this instead. We're going to say print. There are 1,000 ways to do things. We're going to do it this way. What is your name? And then we're going to say name equals input, parenthesis, parenthesis. Now what that does, and then we'll say print name. What this does is this will put it over here and we'll say Dylan. Oh my gosh, you're kidding me. Oh my gosh. I don't know what's going on here. Fine. And now, all right, whatever. I'm not going to deal with it. Sometimes it's going to work, sometimes it's not. I think it's just this particular program that I have running. I could try a different website, and I'm sure it will work fine. So we're not going to deal with that. What I do want to teach you is what is going to be happening here. Now, if you put this in there, Jay, does that work for you?
Almost. All right. Run. Says, what is your name? And it puts me...
Now type something. Type JJ and hit enter.
Enter. And nothing really happens.
Did it print JJ?
No. No.
Okay, of course. This is bizarre. All right, fine. I have another couple programs that will also do something similar as what we're doing here. But I'm not going to try to monkey with this. I have no idea why it's.
Oh, it just did it.
Now it worked?
Yeah.
Okay,
but it
whatever.
gave me an error before that.
Yeah, see, this is programming in real life. Weird stuff happens, and you do the same thing twice, and you get two different results. All right, fine. All right, but we're going to do something with this now, okay? So what is your name? And we print your name. You can see we're getting input from the user, and then we're printing it out. And so now, whatever they typed in goes in as a string into name. Name becomes a string because we type something in.
Wow, I get it.
Okay?
That's cool.
Now, I want you to notice something, though. Like, if we say, how old are you, right? Mm-hmm. And then we change this. Let's say this is age, not name. And I can run this, and I can say, okay, let's say I'm, 25. I'm not 25. Okay, it decided it wasn't going to print it this time, but... Fine. I don't know what's going on here, but age plus 10.
Okay, it's working for me now.
Okay, so now if I print, you notice what I did here? I tried to say,
oh yeah,
age plus 10. Why did that fail? Any guesses?
Because it's a string?
That's right.
Yeah.
Yeah, it failed because age is a string. We typed in numbers. That's right, exactly. So it failed because it's a string. So we need to take what we got and turn it into a number. Then we can use it like a number.
Oh, okay.
Now, do you remember what function we used to do that?
Int.
That's right.
Yeah.
And now, so we can wrap this in int. Okay? So now this looks a little tough to read because we're getting like lots of parentheses. But I'm going to space it out just so you can see the spacing of what's happening. And it does this step exactly in the order that you would expect it to. It does what's inside the parentheses first, and then the stuff on the outside. I'm just going to run it, just make sure. This thing's being super inconsistent. I apologize if you're running into this error, but sorry. At least we'll get it running enough times that it will be workable to learn off of. Does it work now?
Let me see now. Age plus 10.
Yeah.
Okay, age, definitely 12. There, it worked.
Okay,
22.
good.
Nice.
Yeah, because now we're saying, okay, first get the input. So that's this part. Then take that and do int on it, and then get age. So if you were actually look at what was happening in the computer, input would come back with this. Then it would do this work. And this would come back with this. And then 12 is what would get stuck into age.
Yeah.
You got that concept?
Yeah.
Okay, good.
Interesting.
So now we have a way to get input from the user. because we now have a way to get input from the user, we can make decisions based off that input. So for example, we'll just leave this, how old are you? And we want to print one thing if they're older than 21, and another thing if they're younger than 21. And the way we do that is we type this. We type if, and then we have to type something that turns into a Boolean.
Yeah, that's what I was thinking.
Yes, it has to be something that's true or false. So in this case, what could be a true or false that would tell us if they're 21 or older? Like, remember our comparison operators, the things we can use to compare things.
So we have to come up with a question that will come up with
some kind of comparison that will take their age and something with 21 and come back with true if they're 21 or older, and false if they're 21 or under 21.
If
someone in the chat got it.
Greater than 21.
Yeah, close. And someone in the chat actually got it too. If age is greater than or equal to 21.
Nice.
And then we put a colon. And the reason we put a colon is because it says, okay, if that's true, here's the steps I want you to do. And so we hit enter, and you'll notice when you hit enter, it tabs it in.
Yes.
That's because it's noticing, oh, you're doing an if with a colon there? Good, I'm gonna tab in. So anything that's tabbed in will be the steps that happen if that was true. So we're gonna say print, we'll say, oh, hey. And then we'll do another print after that, because I want you to see, you can do multiple lines of code. Stay and have a drink. And then we'll print goodbye. So I'm gonna let you type that in and then go ahead and run it. But this part's really important, the part where we have something that turns into a true false after if. It can be really complex. You can have like lots of things that eventually will come back to a true false, but it does have to be something that's true or false.
Interesting. Okay, so let's see.
Okay, so if we run it,
10.
How old are you?
20. Goodbye.
25. Oh, hey, stay and have a drink. Goodbye. Now, if we run it again and I put, 15, goodbye. Okay, so that's not very hospitable. So let's do something that's a little more hospitable. Okay, so here's the thing. We could write a whole nother if statement, right? We could say if age is less than 21 and then have a whole different thing. But really, we just want, what if this isn't true? Like, if it is true, I want you to do this. But if it's not true, do something else. So in this case, we go back to the beginning.
Okay.
We untab and do else, colon. And it's exactly how it reads in English. Hi. Want some fries? I don't know, I'm just making something up.
Oh, and how come it didn't... Oh, okay.
Don't forget the colon.
The tab is what I was forgetting.
And you just make sure it's tabbed in. If it's not tabbed in, you can hit tab and...
Oh, it's because I put the... I get what I did wrong. I put, next to else, I put the code in.
Oh, okay. Yeah.
So print hi. Okay.
So now if you run it, how old are you? And we'll say 15. Hi, want some fries? Goodbye.
25. Hi, goodbye. I still have the add plus 10.
Oh, really? Okay, so I want you to notice a couple things here, okay? First off, this controls whether this happens or this happens, okay? So this age, this Boolean, this question, true-false question, controls whether this happens or whether this, if this is true, this will happen. If it's false, this will happen. You get the idea?
Yeah.
Now,
okay, so let's see.
Notice the goodbye, though. That happens no matter what.
Yeah.
Because no matter which choice happened, when it's done, it goes back and continues on.
Yeah.
And that's important because if you were to look at our code, this is what it's going to look like. It's going to look something like this. So we have something that happens at the start, and then it goes on and does something else. And then it makes a decision. And this is what happens if it's true. And this is what happens if it's false. So then this happens. And then this happens. Or this, Yeah. And then something else might happen. Like maybe we have 2 print statements, right? You might have a few things happen. Who knows, right? But at the end, when both of these, either of them are done, it goes back and continues on and runs the next thing. So you see how this split off?
Yeah.
It branched. And that's actually what this is called, branching.
Okay.
Is the idea that you can have multiple things happen, but then when it's done, they go back and go back to what they were doing.
Yeah, like a video game.
Exactly.
Yeah.
Very much so, yeah. And so this concept, branching, is really important because you could have something, and if it doesn't have branching, it's not really actually a programming language, because it needs the ability to do different things.
Yeah.
And this is really important to programming, is being able to do different things based on what happens. And this is used, like you said, all the time. Like in video games, this is like constant, Okay, so let's go back to our coding here. All right, now we want a third thing to happen. Maybe if they're less than or equal to 21, but what if they're younger than 5? Right?
Yeah.
So we want another thing to get checked. And the way we do that is we have, after we do if, and before we do else, we're going to do elif. Now, it stands for else if, but they shortened it to elif. I wish they had just left it as else if, but it's just called elif. But the concept is, if this wasn't true, then check if this is true. Now, what we have to do is elif what? Elif age is less than 5. Then we do print hiya. Would you like some juice? Oops, scrolled too far here.
Oh, the caps. I mean the quotation marks.
Okay, so if we run this, how old are you? And we'll say 4. Hi, would you like some juice? We'll run it again. How old are you? 25. Can I have a drink? How old are you? 15. Hi, I want some fries. So you can see we have multiple directions our program can go.
Yeah, let me see.
Are you running into an error?
I might be. Maybe I need to put 4 years old. 4 years old.
Yeah,
Okay,
because
there we
notice
go.
what's the condition that it's asking about?
5 or
Less than 5.
Oh, okay.
So
Less
now
than
is 5 less than 5?
No, it's
Yes,
yeah, so it
exactly.
doesn't do it. Okay.
Yeah, so it is very specific, and that's why you have like less than or equal to, or less than. You have all these different ways. So you notice what the order is here. It's asking this question, and if it's true, it will do that. But if that is false, it'll ask a new question. Yeah. So if this is true, let's do this. But let's say
Yeah.
this wasn't true. Okay, well, I want to check a
got
new
it.
thing.
Yeah.
And then this has to be true. Now, what if that isn't true? Well, if that's not true either, it's going to fall to the else, which is, this is what happens if neither of these things were true.
Yeah.
Okay?
Okay,
And this
makes
happens
sense.
all the time. Like, for instance, like in games, you could say, if the distance was within this radius when the, bomb goes off, then you get this amount of damage. But otherwise, if they're within this other distance, they get this amount of damage.
Yeah.
But if they're not within either of those, they get no, you know what I mean? Like
Yeah.
you can have lots of different, like multiple types of conditions that could happen.
Interesting.
Yeah.
Wow.
And then,
That's a lot.
yeah.
It's a whole world.
Yes, exactly. You can split it up as many ways as you want. Now, the truth is, you can get really complex and crazy about this. In fact, there was a very famous game that had about, I think it was 1,500 of these. all that it checked
my
through.
goodness.
Now, there's other ways to do that are better than that. And you probably should think of programming it a different way if you're writing a program that has 1,500 different possible things that could happen. But they hadn't learned how to do all those things yet, and that worked.
Yeah.
Which just goes to show that if it works, it's the right answer, you know?
Yeah.
Because that game was super popular and has sold probably millions of copies. So, you know, that's just how it works.
Wow.
Okay, so you have this idea, if, and else. Now, the other thing is that sometimes these questions have more than one part to it. Like, remember I said, like, you could ask, like, a really complex question?
Yeah.
Will said someone just posted about that today. About that kind of problem. So sometimes you have things where it needs to be like more than just a single, like, this is true or false. Like sometimes you need to have it like this is true and this is true. If both of those things are true, okay, then do this. Yeah. And the way you do that, 420 characters to choose from, plus exceptions about not duplicating characters whenever selecting the next character. Yeah, that sounds like a lot of code.
Oh man.
Can you imagine typing that and then there's like one error somewhere and then you got to dig through all of that. Oh my gosh, it was all hard coded is a term where it's like you actually typed in everything. Like it's not like, you know, you read it in from a file and then, you know, or like all of those things are listed in a file and just pull them in, like they're actually like coded into the code themselves. Yeah. So which means if there's any problems, you have to go into your code like line by line and figure it out. Yeah, that's rough. So in this case, we want to see if they're greater than or equal to 21 and they are less than, say, 70. Mm-hmm. You know? Well, in that case, that means their age has to be within a certain range. You know? Mm-hmm. We could just do a whole nother, you know, had another else if. So, you know, but that's kind of not quite what we want. We want to do the same thing, the same code, if these two conditions are true. So the way we do that is like if age is greater than or equal to 21 and age is less than 70. So this is at the first condition here. So if age is greater than or equal to 21 and age is less than 70.
Okay.
Now, the reason this works is because it actually does, remember I told you it does all the steps in turn, like this step, this step, this step, and for each line of code. So it's going to look at this question, is age less than 70, true or false? Is age less than or equal to 21, true or false?
Yeah.
Now the way that the and works is both things on either side have to be true in order for the and to be true. Like, for example, this has to be true and this has to be true. If this is true and this is false, then the whole thing is false.
Okay.
Does that make sense?
Yeah, it makes sense.
Yeah.
It all has to make sense. Yeah.
Yeah, exactly. Now there are other ones we can do. So let's say if age is less than, so then if we run this and we say how old are you and we say 75, notice which one it did. Which one did it do?
The want some fries one.
The else.
Yeah.
That's right, because it said, okay, this is true, but this is false.
Yeah.
So this whole thing ended up being false. And now, is age less than 5? Nope, that's false too. So it dropped to the else. Okay?
That's cool.
Yeah. And if we run it again and we say, 65, it treats as if, okay, this was true and this was true. Okay, good. Then we'll do this code. And it skips all of these and then it keeps going. Okay. Does that concept make sense?
That's
we
awesome.
can also do or age equals exactly 80. Okay, so now the or needs only one of the two sides to be true. This can be true or this can be true.
Nice.
And so if we put in 80,
there it is.
Would you like some juice? Because notice this one failed and this one was true, but this one was false. So it asked the next question. And then this one was false, but this one is true, and it's or. So is this true, or is this true? Well, one of them was true, so it worked.
Nice.
Get the concept?
Yeah.
Okay, good. All right, so you can combine or and you can make like really complex questions to ask really complex, things about which way to go, which way to have your program go. Mm-hmm. But this concept is what I want you to understand, is this idea that you can have choices that are made and you can get very specific about how to make those choices. But they're based on this idea of true and false.
Yeah.
So all the questions that you want to ask have to be yes or no questions about your information that you're asking about.
Nice.
Okay?
Yeah.
Okay, good. All right. So now that we have this, we're going to learn a new thing with this. And this is a concept. I'm going to get rid of this.
Oh, that's so sad.
I know, it is sad, right? But it served us well.
Yes.
All right. So what we're going to do now is we're going to learn how to have our computer do something again and again and again. Okay? And it's just going to keep doing it until something becomes, as long as something is true, it's just going to keep doing it. Okay? So let's try this. Let's make a variable called counter. And we'll set it to 0. And now what we're going to do is we are going to say while. While counter is less than 10, colon. Now I want you to notice this is just like our if, it's a true-false question. Mm-hmm. Okay? So while counter is less than 10, print counter, and then do counter equals counter plus 1. Now, do you remember what this does? Counter equals counter plus 1?
Yeah, it moves it to the left. It moves it.
That's right. It's going to take whatever it is, add 1 to it, and then take the result of that and put it back into counter. So it's effectively, it's adding 1 to itself. Mm-hmm. Okay. There's a shorter way to do this that we'll learn later, but for now, this is a good way to understand what's happening. Is you're adding 1 to whatever it is now. Mm-hmm. Take the result and stick it in counter again. Okay. So what this is going to do is every time, as long as this is true, it's going to run this code.
Okay.
Okay, so let's run it and see what happens.
Yeah, goes to 9.
That's right, because I want you to understand what's happening. So when it first starts, counter is 0. Now is 0 less than 10?
Yes.
Good, do this code. So it does this, it prints 0, it adds 1 to counter, and then it goes back. It goes back to the while.
Okay.
It's a loop. It loops back. Now, is 1 less than 10? Because remember, we just upped what counter's holding.
Yeah.
So is 1 less than 10?
Yes.
Yes. So it does it. And it just keeps doing that. Now let's say it gets up to 8 or 9, right? So now, is 9 less than 10?
Yes.
Good. So print 9. All right, 9 plus 1 is 10. Good, store 10 into counter. Now it goes back. Is 10 less than 10?
No.
Right. So it goes, okay, skip, and goes down here. We can even say something like print all done, right?
Oh, that's cool.
And then you can see like, oh, okay, it finished and then printed. Now notice this part is not tabbed in, which means that it's not part of what it's going to do every time.
Okay.
The part that's tabbed in is what it's going to do every time.
Okay.
This concept of doing something again and again and again, as long as this is true, is really important. Because it allows us to have our code keep going until something happens. And you see this all the time in programs. All the time. Like when you've obviously used something like Google Maps or Apple Maps or something like that.
Yeah.
Right? And you hit navigate. How does it know to keep navigating? Yeah. Well, it just says, is their destination equal to where they are now? Their location? You know? And it's like, as long as their destination is not the same as their location, keep navigating.
Yeah.
And so as long as that's true, you know, or like for instance, as long as their password doesn't match what's on file, keep asking them for the password, you know?
Yeah.
I mean, there's like tons of things. You can like even in a game, like while their health is above 0, play the game.
Yeah.
Now, as soon as their health gets to 0, that's, you know, then it just goes on and does something else.
Yeah.
You see what I mean? But like that concept, as long as this is true, keep doing this. You know, like you could have a projectile. As long as that projectile hasn't hit anything, keep moving forward. you know? And this could be a complex question. It could be like, you know, as long as the projectile hasn't hit anything, or the lifespan of the projectile is less than 10 seconds.
Yeah.
So now, either the projectile is going to go for, let's say it doesn't hit anything for 10 seconds. Well, eventually the lifespan is going to get longer than 10 seconds. Okay, well, one of those is true now.
Yeah.
So good. So stop. You know what I mean?
Yeah.
Okay.
That's cool.
So
something I did notice.
Yes.
I didn't. I put it on the. Oh, let me just show you.
Yeah.
I put it on.
Oh
here.
yeah, you put print inside. Yeah, so tabbed in.
Yeah, exactly.
Yeah, so that means it's going to do it every single time. That's right. Yeah, exactly. And so that's why it's important to have it outside, and then it will make sure not to do that every time. Yeah. Okay, good. So you got that concept?
Yeah.
Good. So we're going to use that for right now. We're going to make a guessing game using the information that we have learned so far. Okay? And so this is, we're just going to make a short little game. So first we need the number of guesses. Okay? And guesses, we're going to give them 5 guesses. Okay? Now, in this case, normally in a program, you would come up with have the program come up with a random number.
Okay.
And we're not going to do that just yet. We're going to do that in the next part. But for now, we're going to say, we're going to set what the answer is. We're going to say the answer is 7. Okay? Now, again, normally we would want this to be random. Okay? So we're going to say, while guesses is greater than 0, we're going to do this. We're going to say guess. Now notice, this is guess. This is a variable called guess, not guesses. They're different variables, okay? Guess is equal to the integer version of asking them pick a number from 1 to 10. Now you'll see my code is looping around, right?
Yeah.
That's okay. That's just visual. It doesn't mean our code is different. Because you notice it actually doesn't say that I'm on line 6 here.
Yeah.
Yeah. That's just visual. You don't have to, you can ignore that. And then we're going to say guesses equals guesses minus 1. So that we've used up our guess. Okay? And then, now notice I'm still tabbed in. So this is still going to be what's happening as long as guesses is greater than 0. We're going to say if guess is less than answer, we're going to print if guess is less than answer, print too low, try again. I'll wait for you to catch up.
Interesting.
And I want you to also notice that this is double tabbed in.
Yeah.
Yeah.
Okay.
And that's important because we're still inside what to happen as long as guess is less than 0. But this is what should happen if the guess is less than 0. Okay. Now we're going to say elif guess is more than answer, colon, print too high. Try again. Now notice I back tabbed here to do my elif.
I noticed that.
Yeah. Okay.
Okay, cool.
Now we have 2 choices here. We could say else, right? Because if they answer too low, we do one thing. If they answer too high, do another thing. Now if they didn't answer too low and they didn't answer too high, what does that mean?
They got it.
Right.
Yeah.
So we could say else, hey, you got it.
You win.
Or we could say another elif, which is if guess equals answer, print, you got it. And then, now, what we're going to do here is we're going to say what's called break. And break means stop looping.
Okay.
Because notice we're inside a loop right now.
Yeah.
See all this is tabbed in?
Yeah.
And the break means Whatever loop you're in, break out of it. Okay? Now, the reason I used elif guess equals answer, and remember, the equals compares, doesn't set it. Okay? The reason I use guess equals answer is because this is very explicit. This is like actually checking, did they get the answer? Whereas if we use else, it's just like, well, it's not too low and it's not too high, so it must be the right answer. And so it's implicit, meaning it's deduced that it must be the right answer rather than actually verifying and checking.
Yeah.
Either way is fine in this case. It's just a point of style. So you can do it either way. Okay, so now we're going to hit backspace again. So we're completely outside the loop. And then we're going to say print game over. And let's just walk through real quick what this program is doing.
Okay.
We're setting our number of guesses to 5. We're setting the answer already. We're setting it to 7, but normally we would pick a random one. And then while guesses is greater than 0, meaning as long as they have guesses left, then do this input, pick a number from 1 to 10, but turn that into an integer. Make sense?
Yeah.
So we have to take that guess that they typed in, which comes in as a string, and we have to turn it into an integer and then save it in guess. Because now we can compare an integer with the answer.
Okay.
Because if we put it as a string, it would be comparing a string to an integer. And that doesn't work. Like compare, quote, 5 to 7.
Yeah.
It's like, no, it's like you're comparing a string to an integer. It doesn't work that way. Okay?
Okay.
So now let's run it. Pick a number you want to do. I'm going to pick 5. Too low, try again. 10. Too high, try again. 4. Too low, try again. 8. I'm not very good at this game. Oh, it's doing this super awesome thing where my input breaks. So, I'm going to try. See, not this time it worked. Who knows why?
Too low, try again. 4, 3, and let's try 7. You won. Game over.
Okay, cool. So
Nice.
It works, right?
Yeah.
Okay, good. So mine, I'm going to do 5, 5. Oh, okay. Mine's having issues. You got it. Okay, good.
Nice.
So you can read this code. You have a program that does things over and over again, and it's making choices each time.
Yeah.
Okay? These are like the fundamental building blocks of like every program.
Yeah.
What this allows us to do is we can make decisions and we can do things again and again. And we can be, we're altering variables as it goes. Every time we loop, we're, changing that variable. Again, these building blocks right here are the fundamentals of like everything in code. There's other things we can now do beyond this to make coding easier. But generally, these pieces are the pieces that make up everything else.
Yeah.
Okay?
Cool.
Yes. Okay. So that is a program that you just wrote.
Heck yeah.
Okay. So we're actually doing pretty well on time here.
Okay. How did you said something about making the number random? That'd be kind of cool because then we don't know the number.
It would be cool. So let's and we are going to get into that very soon. Actually, you know what? We'll do it now, just because I think it'd be fun. Okay, so what we're going to do is up here at the top, Will wants nothing but random numbers. Do it now. Okay, so up at the top, we are going to, so right now, you see how we've used like print and int and string to like turn, change variables around, and we have, print command. We didn't have to do anything special. It's just, we can just use it, right?
Yeah.
So there's some functions that we don't just get by default. Okay. We have to tell it like, hey, go get those functions so we can use them, And the way we do that, we do import random. And that says, hey, I want to be able to use a bunch of functions that have to do with random numbers, okay? And once we do import random, now instead of answer is 7, we can do random rand between, and then we give it a number, like 1 to 10. Okay?
Okay.
Now I'm going to run it just to make sure that it works. Oh, hold on. I have to look up real quick what that function is called, because I think... I thought it was rand between. Oh, maybe it's... Oh, I think... Hold on one second. Okay, sorry, my bad. It's called rand int. Random integer between 1 and 10.
Oh.
There we go. Now... we can say, now we can really go to town and actually, too low, try again. Okay, 6, too low, 8, too high. It actually picked 7.
Low.
All right, hold on. I'm just to make sure. Okay, good. Ooh, I picked it. What happened?
Mine just said, wait, I picked 1, then I picked 5.
And then it just like
Nothing
stopped.
happened. Yeah.
Okay, so just run it again, because I found that it's just, I think it's just this website. It's inconsistent when it's getting input from the user. That's all.
5,
So just run it again. I've had a few times now where it's just, oh, I picked it first try. All right.
Dang.
All right. We're going to try it again just to make sure.
Nice, you won. Heck
Yeah, this thing is really finicky. Too high. Too low.
And so you can change the guesses too. You make it harder. You can do like 3 guesses. Or
Yes,
something
exactly.
Like
Yeah, so that is game design.
That's so
That's
cool.
deciding, you know, is this hard enough? Do I make it easier?
Let's see.
Make the Dark Souls of guessing games.
Run. 3. Oh, you won. Game over. Nice.
Yes, I do actually have other tools to suggest other than this website. So, for example, there is this one. This is another one that lets you do it. This is another one. There is also a site. I'm going to have to type this in because I don't have it offhand. But you have to log in to use it. And but I use this for my coding classes. That's one that's also usable. So those sites are, I pasted them in here. You don't have to worry about it right now. But
Okay.
Those are sites that are also allow you to just type in code and run it. And unfortunately, we're not going to go over how to install Python and all that kind of stuff because we just don't have the time for it. Because I want to keep it simple. But this one, if you just run it again, if you run into that error, you can run it again. Now, I want to explain a little bit what's happening. So I did tell you import random brings in a bunch of functions, right?
Yeah.
So this part where I did random.randint, sometimes you have things here where you can run a function off of it, like dot this, you know? And it's just a different way to write out running functions. And this one, like if you wanted to learn how to do this, like you literally can just type in, like to Google, like Python random numbers and see how you do that. And then knowing exactly why it's written that way, not super important at this point in time, but you should know that like most of that code you can find online. You can copy and paste it into yours and then tweak it to see if it works for you.
Nice.
You know? But this gives us access to some extra functions. And you see I didn't just type in randint like this. I typed random.random because when I said import random, that said, hey, I want to be able to get to these functions using this word random. And now I can dot, and it's kind of like, hey, as part of those random functions, I want the randint function. Okay?
Cool.
Okay, good. So we just made a random guessing game,
Nice.
and you could, you can make it really hard. We could say between 100,000.
Oh my goodness.
And now we've got a really hard guessing game where you have 5 guesses. Let's see if I can do it. Let's do 250,000. We'll just, 50,000.
There's no way.
I'm going to get it in 5. Too low. Try again. Oh, okay. Let's do 25,000. Too low. Try. Oh, I did. I went too low. Okay. 75,000. Too high. Okay, we're just going to shot in the dark here. It's a 43,752. Oh, it broke. Okay.
Okay, again.
Oh, when I said between 1 and 10, I should be saying between 1 and 10,000. Okay, so this is actually a perfect example. So you notice it says pick a number between 1 and 10. That's a problem, right? So let's fix that. So let's do this. Let's make a variable called high number.
Okay.
And what should we set it to? Let's set it to 100. And let's make another variable called low number. And let's set it to 1. Now, notice we can replace these hard-coded numbers in here with variables. We can say random between low number and high number. And you see what that does?
Wait, no, I missed that.
Good, that's fine. So we made 2 extra variables called low number,
and
we set it to 1. So low number is storing 1, high number is storing 100. And then when we go to use this function, instead of typing in numbers directly, we are putting the variables so that when it goes to run that line of code, it replaces the variables with whatever low number is storing and whatever high number is storing.
Okay, high number.
But you'll notice it still says pick a number between 1 and 10.
Yeah, I changed mine to 1,000.
Well, we want to change our pick a number question, right?
Yeah.
So that this is going to look a little complex, but I want you to understand what's happening. We can say pick a number between from quote plus, and then we have to turn this into a string. Remember, because it's an integer. String low number plus, and we do a space, and then another space, quote, and this is where it starts looking odd. Okay.
Low
plus
number,
high number. Oh, sorry. We have to put that in a string. String high number. And this also starts looking messy because of all the parentheses. Man. You see why this is a problem? Plus, I'm gonna make my text a little bit smaller here just so we can fit all this on. Plus quote colon. And I want you to we'll look at what this all means once it's done.
We'll see if I get it right.
Yeah, no, this is an area it's totally ripe for making errors, and that's okay.
Quote, and that's a colon. Yeah.
Yeah. Now I want you to look at all we're doing here is we're building a string. We're building a big string.
Yeah.
So we're saying quote, pick a number from, and then we're saying okay, that's one string. And then we're going to stick onto that a string version of low number.
Okay.
So pick a number from low number, and then we're adding another string, which is the separator between low number and high number.
Yeah.
Okay, so if you look at this is one string, another string, another string, and another string, and another string. We're just stringing together strings.
Yeah.
You get the idea?
Uh-huh.
So it's just like string plus string plus string plus string plus string. So we're just,
but
we're building it using our variables.
Okay.
And then don't forget we have 2 parentheses at the end here. One is the parenthesis for input, that's this one. Mm-hmm. The other is the parenthesis for int.
Yeah.
Okay?
Okay.
So now when we run it, it's going to say, okay, pick a number between 1 and 100. Now notice it's using my numbers.
Dang it.
So I can change this. I could change this to 2,000, and my low number can be 46. And now when I run it, see, it changes my pick a number from.
Wait, I think I know what I did wrong.
Sure. I'm going to try to guess mine. Let's do...
Wait, something in line 9.
1,000. Too low. All right, 1,500. Too high. 1, 2, 4, 2. Oh, 1, 3, 6, 8. 7, 8. Oh, I have one chance. 1, 4, 8, 7. Oh, it was 2. Okay.
Oh, I found it.
You found the error?
think so.
So again, if you run into errors, that's okay. That's totally fine if you run into errors.
That's a plus next to string on line 9,
right? Plus next to string. You should have pluses next to them.
Okay.
There are other ways to build strings that aren't quite so messy.
Low number equals. Oh, that's why I'm changing. Oh, I get what I did wrong. I put in a bunch of equal signs instead of plus signs.
Oh, yeah. That will mess it up.
There we go.
Does it work now?
From 1 to 1,000. Okay, let's try.
Okay, good.
This.
Good luck. You have 5 chances. Well, I don't know. Maybe you made yours harder.
Oh, it crashed again. Okay, 500. Too low.
Good luck.
Okay, I only have 3 guesses. Too
Yeah,
low.
you only have 3 guesses.
750. Too high.
Oh, now you got 250 numbers to choose.
632. That's the one. Oh, it broke.
Oh, that's too bad. Okay. One thing I do want to mention here is, see how I named this low underscore number?
Yeah.
That's because variable names have to be one word. To the computer, they have to be one word. Now, obviously, low number is not one word, and low underscore number, still, we don't think of it as one word, but the computer thinks of that as one word.
Yeah.
Because it's got that underscore there. But we use the underscore because then it's easier for us to read it like 2 words.
Yeah.
But the computer still looks at it and sees
Low
one
number.
word.
Yeah.
Make sense?
Yeah.
Okay, good. All right, so we have a working program here. We have a working guessing game that has random numbers, and it uses all the concepts that we've learned so far, which is we have strings, we have integers, we have booleans, because like guesses is greater than 0. That comes down to a true false, you know. We have these other things, if guess is less than answer. We have the if, which checks to see, like it does different things based on what they answer. We have a while, which loops every time, okay? Now again, these concepts are the building blocks of almost all code, okay? You have types of information. You have variables to store those types of information. You have if, which allows you to make decisions based off something. And you have loops, which allow you to do something again and again and again until something is true or not true, right?
Yeah.
Good. So what we're going to do, we're going to take another break. Just, you know, get some water, go to the bathroom, whatever needs to happen. So we have one question. Would building a string be done differently if this was a game that required it to be translated to other languages? Absolutely. That is very true. So do you notice how we have this string right here called pick a number from, right? That right now is in English, right? Well, the easy thing that is the way that you would translate this to some other language would be you would make a string called like, we can call it like English question equals pick a number from, okay? Now, JJ, you speak Spanish, right?
Yeah.
Good, so we can make a Spanish question. What would the Spanish version of pick a number from?
Escoge un número
You will have to spell
de
for me because
ESCOJE. Escoge un nice número. Nice. I guess you would say DE.
Okay.
Yeah.
Good. So these are 2 versions, right? Now what we can say is if we can say question equals, and then we can choose one. We can say English question, right? And then instead of right here, instead of saying pick a number from, instead of typing that in directly, we just say use the question variable. Now look, right now, what is the question variable holding? Whatever's in English question, right? So question is just holding whatever's in English question. So now if we run it, we get that, right? But if we change this, so question is now holding Spanish question and we run it, we get the Spanish version.
Oh, nice.
You see? So right there, all we had to do is change this from English to Spanish. Now, this could be an if statement where at the beginning you say Spanish or English.
That's so
and then
cool.
whatever they type on, if answer is Spanish, then question equals Spanish question. Else Spanish equals English question. And that is how you can use variables and if statements to give different, different things like, a multilingual guessing game.
Yeah.
Does that answer your question, IceCube? Because this way that they do it really is how games do that. They any places where they have to print out a string, like in dialogue or like in labels of stuff or like any text that's in the game, they just have a whole list of all the different versions of that for the entire game. They have, here's the version of this piece of dialogue in English, Spanish, French, German, Japanese, and then based on which language they've chosen, it just picks the right string for that. And then that, if they want to do, let's say I don't know, Italian version, they would just make new Italian versions of all of those strings and do it. And it doesn't have to be strings too. Like you could say, play this audio file. No, play this audio file. No, play, or even put this texture on the wall. And it's like an Italian version of stop, don't go further. And then, or put the German version of, German, don't go further, Okay, so that is good. So we're going to take a break for about 5 minutes here. And then when we come back, what we're going to be doing is we're going to learn how to make lists of things so that we can have more than just like a single thing at a time.
Okay.
And, see like, is it in this list? Is it not in this list? That kind of thing. And we're going to learn how to make our own functions so that we can make functions that do stuff instead of just relying on what's already built into Python. Okay?
Nice.
Okay, good. Yes, it does take a lot of manpower to translate each line. That is why often you will see in games, you'll see people in the reviews like, talking about like, why isn't this in this language, and they just expect the devs to just like do it like that. But translation is a big job. Like it takes a lot of work, and this is also why it's important to not skimp on that aspect of things too, because you want to pay a good wage for someone to translate your work. Because you want it well translated. You're absolutely right. It is a lot of work. Okay, so we're gonna take a break. I'm gonna hold on one sec. I'm just going to switch over to here, and we're gonna say, oops, back at. What time is it now? 3:02. Oh, right. We'll be back at 3:07. Okay, good. Alrighty, give me 1 second, and then I will see you all in 5 minutes. Okay, we are back. All right, so we're going to do this last segment here, and we're going to learn how to make lists of things, because that's a very important part of coding, is being able to work with lots of things, not just a single piece of information. And then we're going to also learn how to make our own functions that can do things for us, and saves a lot of time. Okay, so the first thing we're going to do is I'm going to go back. Before I switch over here, I'm going to get rid of the guessing game. If you wanted to save it, you could copy it into something else. Or you could just open a new tab and do another, go back to the same site and then have it open in 2 tabs. But I'm going to start it off. So let's switch back to coding here. We're going to make a list of things. Okay, now the way we make a list is we use square brackets. So I'm going to show you how that works. So let's say we did name1 equals Dylan, name2 equals JJ, and name3 equals Will. Okay, so this would get really cumbersome if we started having to store hundreds, thousands of names, right?
Yeah.
Even if we had to store like 5 or 6, it would still get cumbersome, right?
Yeah.
Especially if we wanted to add new names that weren't part of what we originally started with. Okay, so that we don't want to just sit there and make a new variable for everything we want to store, right?
Yeah.
Also, because we can't. Our code is our code, so we can't just like dive in and change the code in the middle of while the program's running. You know, you just want the code to be flexible. So instead, what we're going to do is we are going to change this and store one variable called names. And we are going to tell it to store multiple pieces of information. And we do that surrounding it with square brackets. And we put each information in this thing. So we can say Dylan and then a comma outside the quotes. Notice it's outside the quotes, okay? It's really important because this is its own piece of information. Dylan, JJ, quote, Will. And it's really important. Notice that the commas are outside the quotes. So this is square brackets around this with commas in between each item.
Yeah.
Now,
I have a question.
Yeah, absolutely.
It might be dumb, but after the comma, do you want a space or?
It doesn't matter.
Okay.
It's a style thing. It's usually you have a space, but that's a good question.
Okay.
Okay, so we now have this variable called names. If we print names and we run that, it literally just prints, here's your list, okay? But let's say we only want one of those names. To do that, we can get to individual items with a number. Now, the way computers like to number things, it likes to start numbering things at 0. So this becomes the 0th item, and this becomes the first item and the second item. Okay, so this has the number 0, the number 1, the number 2. Now, you know how, like when you look in the back of a book, you have an index?
Yeah.
That tells you like, oh, that's where this thing is. And it gives you like a page number. Okay, so the index is the name of that number. So the index of your name in here is 1. The index of Will's name is 2. Does that make sense?
Yeah.
Good. So you use the index with square brackets to say which one. So if I want Will's name, I would do square bracket 2. So I do print names, square bracket 2. And that says I want the index 2 item of names. And I hit run, and we just get that name.
Okay.
Don't forget to use names and then square bracket.
Oh, I did name
2.
Names.
Yeah.
There we go.
Make sure it says names. Yeah. Okay, does that make sense?
Yeah.
Good. And then if I can use this, I can say names 1. And that's how we can just get to each individual item. Nice. Now the cool thing is you can actually build this list and you can make it get bigger and smaller and you can add things onto it. So for example, I'm going to do names append, and this is a function I'm doing on the names variable. That's why it's dot append, is because it actually is running this function on this, meaning it will affect this. And what name should we add?
Bob.
Bob. Okay, so names.append Bob. And now I could do something like this. I could go to the third item, which didn't exist at the beginning, 0, 1, 2. We don't have a 3, right? But now we do. So if I run it, you can see. Now we get both of those, okay? We can also find out how many items are in this, okay? So I can say print, and then I'm going to add some spaces here. You don't have to add, I'm just adding them to make it clear. The function len, in parentheses, you can put a variable, like a list variable, and it tells you how many items are in that.
Okay.
There we go, 4 items. Now, if I copy this and paste it up here before we append Bob.
Okay.
So you can see we have 3 items. Yeah. Now we append Bob. Now we have 4 items.
Interesting.
We can also do stuff like, let's say I want to get to something from the opposite direction. Like, you know how we've been counting 0, 1, 2, right?
Yeah.
We can actually go the other direction too. Like, I want the last name that's in this list. I can use negative numbers for doing that. And if you go -1, that says count from the back of the list. So names -1 will give me Bob, the last one.
Yeah.
Does that make sense?
Yeah.
If I do -2, then it does Will. So you can count from either direction.
Nice.
Okay? And this is really useful. You can store lots of stuff in here, and it doesn't have to be strings. You could store numbers and booleans and strings or whatever you want. Okay? So I'm going to show you something else too. So I'm going to get rid of these things. So we have this list here, right?
Yeah.
I'm actually going to make the list longer right here. Bob, we'll add Marlo and Corey. Okay, so we've got a list. We've got a bunch of names here.
Yeah.
Okay, so we're going to print names. Run it. And we have this big long list. Okay, I want to get only the names from Will. Does names have to be the same type of information? All ints? No, it does not. You can mix it. So you could put strings and then numbers and then booleans. You can mix them all together. It's just items in a list. So yeah, you can store whatever you want in there. And this is really useful when you have like a lot of information to store. You want to store it all together. So I want to get the name Will and through Marlo. So what I do is I can use a thing. This is called slicing, and it's a special feature that Python gives of working with lists of stuff. Python is a language that's really good at letting you manipulate lists of stuff. Okay. And because it's really good at manipulating lists, it's used a lot in science. Because science, you're working with tons of data and tons of lists of things. And so for that, you want to be able to work with like data a lot and fast and be able to do really clever, interesting things with it. So science tends to use Python quite a bit. So what we do is we start off with what's the first item we want. Now, what's the index of Will?
2.
That's right. So we say start at 2, and then we do colon, and we go up to, but not including, up to, and let's say we want to get through Marlo. So what's the index of Corey?
Wait, 1, 2, 3, 4, 5. 5.
0, 1, 2, 3, 4, 5. That's right. You can also do -1. That also works.
Oh yeah.
Because
last one.
5 and -1 are actually the same position in this list.
Okay.
So we can say go from 2 up to 5. Now it doesn't include 5, it just goes up to 5.
Yeah.
And if we print that, look what we get.
Oh.
We get a smaller list. Okay? So this allows us to kind of like slice up this list in different ways. We can say, again, I can also do -1, right? Same thing.
Okay.
Now, the other thing is I can do, if I don't leave anything in there, and I just put a colon, that means just go to the end.
Okay.
Like, I might not know what the end is. I just want, just go, start from 2, go to the end. And if we run that, you notice we get Corey as well, because it just goes all the way to the end. And you can also do things like, you can say, start at the beginning, and go up to the second to last name. You see what I mean?
Yeah.
So we can just say start at the beginning, and then go up, and then it gets start at the beginning and goes up to the second list. So there's lots of ways you can do that. We're not going to go into all the ways you can do that, but I just want you to see, like, you can kind of play around with these and get, like, different parts of it.
Yeah.
Okay? And it's really useful. Here's another thing you can do is we can take names, and we can say names.sort. Now I'll print names. Now remember, with this thing where we did dot sort, right?
Yeah.
That's because this function is specific to a list of things, and it's going to do this function on this list.
Okay.
Okay? Make sense?
Yep.
Now let's say you don't remember how to do that. And you're like, well, I don't remember how to sort a list. You can literally go into Google and type Python sort list, enter, and you'll find the code to do this. And it's really easy to look stuff up like that. So it's not important you remember this. It's just important you remember there are things you can do to lists like this. Like, let's say that you want to reverse the list. Fine, you could just search on Google, and like you just Google Python reverse list, and then look at what the code is for reversing a list. It's really easy.
Cool.
But now I want to show you something else. And that is the fact that if we do this, let's say we do place equals Portland, okay? Now, remember I talked about how strings are, like, they're characters all strung together, kind of like those bead bracelets, you know, make as a kid. They're like just strung together. That's a list of characters.
Yeah.
And because a string is a list of characters, you can treat it like a string when you want to dive into and get pieces out of it.
Interesting. Yeah.
And each character has its own index, has its own number. So in Portland, with the index of P is 0, and O is 1, and R is 2, just like this. It's if you treat it like a list of characters. So let's say I wanted to get land. I could do place, square bracket, and then how would I get land out of that?
Land?
Yeah. What's the starting index? What's the index of where land starts?
Oh, 0, 1, 2, 3, 4.
Okay, we'll start at 4 and go up to what?
5, 6, 7.
Okay, so we want to go up to though.
Oh, so 8 technically.
We could do 8, right? Even though that's not actually
There's
a
not
spot.
one,
But you can also leave it off, and it will just say, go to the end.
Oh, yeah.
You know, that's another way to do it.
Yeah.
You know, so if we run this, there we go. We got land.
Wait, run it. Oh, I see. Oh, cool,
Yeah.
cool.
So you can treat a string much like a list where each thing is a character.
Okay.
But it just, you know, it has a lot of the same kind of things where you can do it. You can do that kind of stuff, which is kind of nice, you know, because it lets you do interesting things with it. Okay. Does that make sense?
Yeah.
So I want to keep this list of names, okay? So I have a question. As someone who is used to C++, the statement place equals, quote, Portland just feels so wrong. I do understand. Yes. Okay. So what we're going to do now is we are going to do the concept of a loop, but a loop that goes through a list.
Okay.
Okay? And the way we're going to do that is we're going to do a loop where we're going to give the loop a list, and we're going to say, I want to do something with each item in this list. And each item in the list, as you do with it, as we go through it, I'm going to have you put it in a variable name so that I can use it each time we go through.
Yeah.
This is kind of like if I wrote all of these names on slips of paper, and I said, okay, we're going to go through each of these names, and I'm going to hand you a slip of paper. Now, you might not know what the name is, but you might have instructions to do something with that slip of paper that you call name, right? Now, your instructions aren't going to change. Your each instruction is going to be like, you know, print the name.
Yeah.
Well, the name each time is going to be different, every time I hand you a new slip of paper, it's going to be different. But your instruction is print the name is going to be the same.
Yeah.
Does that make sense? So let's make a loop. It's called a for loop. And we're going to say for name in names and a colon and then hit enter. And what this does is this is our list.
Okay.
Right?
Yeah, that's right.
And then we're going to say each time you go through this list, put that current name, that current item in the list in this variable called name.
Okay.
So you notice we don't have a variable up here called name. We have one in here.
Yeah.
Okay. So now what if we do print, not quotes, print name.
Okay.
And then run it.
Nice.
So you see what it did there. It just goes through every item in the list, and it puts each item in this variable each time we go through so that we can do stuff with it.
Oh, cool.
Like we could say print name, then we can say print hello space plus name. Right? And then we can print goodbye. You see? So we can do things with name each time.
Okay.
Right?
Yeah.
And then print, and you'll see it does.
Doesn't.
You see what it does? It does that set of code with each item in the list. And you can see, so it's going to do all of these, and name will always be whatever the current item in that list is.
Okay. Nice.
Any questions on that?
Nope.
Okay, this is really useful. The ability to go through every item in a list. Okay, because there's a lot of times you need to do something with each item. Okay. What I want to show you now is how to go through, how to use this same kind of, the other thing I want to show you too is, see that name variable?
Yeah.
Let's try to use it after we're done with the list.
Okay.
Let's print name after we're, now remember it has to be outside the indentation.
Yeah.
Okay, so I'm going to try to run it. Doesn't work.
It did.
Oh,
What
it did.
It do?
Oh, okay. Usually it doesn't. Usually, all right. This is an interesting thing. Usually this dies, but okay, fine. We're gonna leave that. We're gonna leave that topic for now. Okay. So what we need to do now is we're gonna try to do something where we don't want to go through a list of items in a list. We want to go through a range of numbers.
Okay.
Like we want to do something 10 times. Okay. And so the way we're gonna do that is instead of putting a list of things here, we're going to put, we're going to change this up. I'm going to get rid of all of this and then we're going to hit I, and then you don't have to put I, you can put whatever you want. You can put I, J, L, lawnmower, it doesn't matter.
Okay.
The reason I'm using I is because it stands for index.
Okay.
And it's often it's often a variable that's kept as like when you're looping through something a number of times, I is often used in code to keep track of what's the current number.
Okay.
So we just use I because it's easy to remember. For I in range, and then we'll say 10. And we'll say print I. And we'll see what happens. Run it.
Print I. Oh, what did I do?
Don't forget range parenthesis 10.
Parenthesis 10. Oh, yeah.
And make sure you have a colon at the end.
Oh, yeah. I put it. There we go.
Good. Did it work?
Yep.
Good. What did it count up to?
9.
Up to 10.
Up to 10?
Up to 10. Now, how many numbers did it print?
10 numbers.
That's right. It did 10 numbers because it starts at 0.
Yeah, that's right.
Okay? Now, you can change that. You can say like 5, 10.
What does that do? Oh, yeah.
And that says start at this number and go up to this number. You can even do stuff like you can say, let's go 5 to 10, but comma, let's skip every other number.
Oh, interesting.
Or you can skip every third number. or skip 3 numbers each time. You get the idea?
Yeah.
So you can get really clever about how you make this range of numbers. But usually the way you're going to do it is you're just going to put, I want to do something 10 times, right? And you don't even have to use the I variable. You just want to do something 10 times. You want to say, let's say you want to print hello 10 times. Well, that will do it 10 times, you see? So whether you use the I or not is not super important. It's just that you can use it if you want to.
Yeah.
You know, but it allows you to do something a certain number of times.
Yeah. Okay.
Okay?
Yeah.
Now, it is useful if you do have to keep track of something. Like, for example, like, let's say you want to do something this number of times. Well, do you remember how we find out how many items are in this list? There was a function that we could use. We didn't use it a lot, so if you don't remember, it's okay.
I don't remember.
Yeah.
I know we just did it.
It's called len.
Oh.
That's right. Someone in the chat remembered.
Oh, wow.
So len, parenthesis, and then names. So len names comes back with a number, right? And this is an example where I was talking about where the computer does all the parts of the code, like one piece at a time before you get to the final result, right? So len names, that's going to happen first.
Yeah.
So first it's going to figure out, well, how long is names? And it's going to come back with a number. It's going to come back with 6. And then that's the same as typing I in range 6. You get the idea?
Yeah.
How that's the same? Okay, good. So if we say for I in range len names, now if we were to print, I, we get 0 through 5, right?
Yeah.
We can use that because watch. Remember we can put a number in the square brackets to get a specific name?
Yeah.
So we can do names, square bracket, I. Now each time we go through, that I variable is going to be different.
Nice.
See how that gets each
Yeah.
name? Now there's an important reason we did it this way. And the reason we did it this way, why didn't we just put 6? I mean, wouldn't that work? Yeah, it does work, right? But then what happens if we put 7? Right? Because we're trying to get an item that doesn't exist.
Yeah.
But if we're using len, we're always going to get the right number of names.
Okay.
You see?
So if we add names, it'll...
Yeah, we could, if we put 6 there, that means that if we change that size of the list, our code's broken.
Yeah.
But if we put len names, that means it's always going to be up to date.
Nice.
We can add we can say names dot append. We'll put Spud, my dog's name. And now it's going to do all of them. We didn't have to change the rest of our code. We just had to add a name, and it now automatically knew, oh, okay, do the current new number of names.
Nice.
And will work. And you notice we're using I here just to refer to this.
Yeah.
Okay. Does that concept make sense?
Yeah, it does.
Okay, good. So this is really useful because it allows us to go through, make lists of all sorts of things. Okay. The last thing I want to point out is sometimes you can have a list of lists.
Okay.
Okay, and I want you to think about that for a second. Okay. Okay.
Yes.
So the way we're going to do that is, let's say we have a list called people, right?
Yeah.
Oh, I can't spell people. Okay. Now this list might be, each item in the list is its own list. So like for example, we might have their name and their favorite color and have they been to Italy, right?
Yeah.
Comma, and then the next item in the list, which will be JJ, what's your favorite color?
Blue.
Okay.
Baby blue.
Baby blue.
Yes.
Okay, baby blue. Comma, have you been to Italy?
Yes.
True. Okay. Then we can have another person here. I don't know. I don't know if Will's been to Italy or not. Will, what's your favorite color? If you're there. Or someone else. I'll say Will's favorite color. I don't know. I don't want to assume his favorite color, so I'm going to put pink. Whatever. Okay, we'll do pink because it's the color of Cube Pig. And Yeah, see, there we go. We're thinking on the same page here. And I'll say you have been to Italy, just because. But I want you to notice, this is a list of 3 lists.
Yeah, lists within lists.
That's right, lists within lists. Now watch what happens. If we print people 1, and we run it, notice what we got back is 1 list.
Yeah.
Now what if we wanted to get to your favorite color out of this list? Well, what's the index of the second item?
We don't have one, do we?
Well, it starts at 0, because all lists have an index for each item.
Uh-huh.
So we have 0, 1, and then 2, right?
Oh, yes.
But this is the item 1 of list 1, right?
Yeah.
And this would be item 2 of list 1.
List 1, yeah.
So we can do that. We can say this. We can say, and that will come back with true. Or we can say item 0, right? And that will come back with JJ. Now I want you to see what's happening here, because this can get really confusing.
Yeah.
Right? Because remember how the code does every step each at a time?
Yes.
So let's think about what happens here. Okay? So if we print people bracket 1, bracket 0, all right? That's like, okay, what's happening there? Well, what is people 1? What is that?
Is that Dylan?
No, we have 0.
Oh, 0, yeah, me.
1. That's
me.
right.
Yeah, yeah.
So this list is item 1, right?
Yes.
So now what if we took this list and we said, you know what? That is item 1. So then we're saying, okay, of this list, I want item 0.
So then JJ is 0.
That's right. So then it says, okay, we want item 0 of that list. So that's what eventually the print statement comes back with.
Interesting.
But I want you to notice that it does it one step at a time. Like when we say people 1, bracket 0, we're saying get the first item. So that would be, or not the first item, the second item actually. Yeah. Get item 1. Then of that item, get item 0.
Yeah. Interesting.
Because it's doing it one piece at a time, one step at a time. So it's going to get this, replace this, and then it's going to go, oh, well, I have a list now, so get item 0.
Item 0.
Okay, good. Does that make sense?
Yeah. Makes
Okay,
sense.
good. All right. So that's lists. There's a lot to learn about lists. This is like barely scratching the surface of lists. But I want you to understand that lists of things are really important to coding.
Okay.
I only have a question. Is there a way to have it print the number with the list item? So for example, if I had a very large list of 100 items and need to know what Marlowe was for, that I easily see information. Yes, you can, because notice when we go back to, let's do for I in range len names. Okay, so remember we did this and we were printing each, like we did names bracket I, right? So we just did this. Remember how when we do this, we're just saying, okay, go through all of the items in the names list and print each item, right? I is just a variable. It's just storing what's the current number we're at. So we can use it just like any other variable. We can say string I, like turn I into a string, and add it to the name. You know, maybe we'll add a space or a colon like this, right? So that it looks a little better. But I want you to notice what's going to happen there.
Oh.
Because I is just the number that we go through each time. So we say, okay, well, turn it into a string. And then add it to this little string of a quote space.
Yeah.
And then go use that number to go get that item in the list. So each time we go through, I is just currently happen to be the number that we're at.
Yeah.
And you can use it just like any other number. You know, in fact, if you didn't want it to start at 0, you could even say I plus 1. Like you could say, well, give me whatever I is plus 1. And now we have a list that starts at 1 and goes to 6, you know?
Yeah.
Because maybe we don't want the programming number of what they are. We just want to like see, you know, just make me a numbered list, you know?
Yeah.
Does that concept make sense?
Yeah.
Okay, good. Okay, so what I was saying was like lists are really important in coding because so much of what we do in coding has to do with lists of things. Like if you're in a video game, you're going to have a list of every projectile on the screen.
Yeah.
And you need to do something with each projectile on the screen. Like for projectile in projectiles.
Yeah.
You know, like for each projectile, okay, where is it now? How fast is it moving? Update its position. Check to see if it hit anything. If it did hit something, do damage to it. All right, next projectile. It's moving. How fast is it moving? Update the position. Did it hit something? It did. Okay, do damage. You know, next projectile. And it's going to do that with every projectile in the game, every frame of the game.
Yeah,
you get the idea? Like, it's crazy. Yeah. Now imagine like a big multiplayer game. You've got like all these people running around. It's just doing lists and lists of things going on in the game. And that's really how that kind of stuff works is, you know, if you're, you know, dealing with, you know, navigating in Google Maps, it's going to list like, okay, give me a list of all the streets and which streets am I driving on? Okay, what's the go through? Okay, for each street in my route, for street in streets, right? What's the speed and how far am I driving on that street? On that street. Okay, good. That's a length of time. Now I'm going to spend 20 minutes on this road, 1 minute on this road, 5 minutes on this road, and then at the end I have a total minutes.
Yeah.
That's the length of my drive.
Wow.
You get the idea? Like, but that's what it's doing each time. It's just going through the lists and doing stuff with them each time.
Yeah.
Okay. All right. So now, last thing we're going to cover in this workshop is how to make our own functions. Okay. So sadly, we're going to say bye to this list of stuff. We're going to clear this. So now, the way functions work is they're just a chunk of code that you tell it to run, and it just runs that chunk of code and then keeps going with your program. And there's two parts of it. One, you have to tell the program what that chunk of code is and how to run it.
Yeah.
And then there's another part, which is you actually have to tell it to go run that chunk of code. It's the difference between, like, let's say I wrote out a list of instructions on how to clean your room.
Yeah.
And I hand you that list of instructions. Okay. Now, does that list of instructions automatically equal a cleaned room?
No.
No, you have to do the list in order to have it actually happen. Now, I could hand you that same list of instructions a bunch of times. The instructions don't change, but each time I tell you to do it is a different time that you're going to do it.
Yeah.
And you can run that list of instructions as many times as you want, and you can clean your room as many times as you want.
Yeah.
But the list of instructions has to be written first. Okay? So that's what we're going to do with a function. And we're going to define a function. So let's just make a simple function that just adds two numbers. Okay, that's all it does. So we'll say def, which means define, and we'll call this addition. Now remember, all the functions we've been using so far have parentheses.
Yeah.
Okay, and the parentheses are there so that we can give the function information.
Yeah.
So we're going to put parentheses here, and in here we're going to put in two variable names that we want to use for the two numbers that we are given to add. So we'll just say A and B. Doesn't really matter. We could call these A and B. We could call them num1 and num2. You could call them chicken and cow. It really does not matter what you call these. We're going to call these A and B, though. And then we're going to put a colon. And we put a colon because just like if and while and for, it means like, okay, what's coming next is what is relevant to this, okay? So we hit enter. And notice it already tabs us in. So we're going to make a variable called total. And we're going to set it equal to A plus B.
Okay.
Good. So this is just saying whatever we're given that's A and whatever we're given that's B, add them together and store them in a new variable called total. Okay. And we're going to return total, which means give back this information. Because, you know, a lot of functions that we use, we need information back from them.
Yeah.
You know? And now, if we run our code, nothing happens. Because all we did is we defined how to add something. Yeah. We didn't actually do it.
Okay.
So we can say sum, or not sum, we'll say my total, my underscore total equals addition 5, 3. There we go. Now I want you to see what's happening here. This is we're actually running our function.
Yeah.
We're actually saying, go run this function called addition, and here's the two numbers that you need.
Yeah.
Now, which number will go into A?
5.
That's right. And which number goes into B?
3.
That's right. And we're going to make another one called total people equals addition 12, 4. Now you notice we didn't have to write new code on how to do addition. We could just run our function again.
Yeah.
Okay. Now if we run this code, still nothing appears to happen, because all we did was we just made a variable that stores the result.
Yeah.
We haven't done anything with that. So we're going to print my total, and we're going to print total people, just like we've been doing.
All right.
Does that make sense?
Yep.
So we have my total, which took 5 and 3 and added them together, and then gave us back an answer. And that answer, so remember I told you about how like the computer is doing each step, right?
Yeah.
So first it's going to send this off, send 5 and 3 off to addition. And what's going to come back is the total, right?
Yeah.
And it's going to replace this with whatever the total is come back, and then that number is going to get stored into my total. Same thing here. Does yours work? Or are you running into an error?
I'm running into an error. Oh,
Good, what is it?
I know what it is. I spelled total wrong.
It happens.
Yeah.
I was
Okay.
spelling people wrong. Okay,
There we go.
so you see what happened there? We're
Yeah.
just running this function, it's doing its job, and it's giving us back an answer.
Yeah.
And
must
then
be-
that answer is then what gets stored into here.
Cool. It's like spreadsheets. Like.
Yeah, it is. Yeah. Now we could even use this multiple times. We could say addition plus addition, 5, 2,
Oh.
We can use it multiple times. And again, this concept that the computer's just going to do all the work before it stores the answer is what's happening here. It's going to do all this work, then it's going to do all this work, then it's going to add those results together. That result is then going to get stored in total.
Cool.
Make sense?
Yeah.
Good. The other thing I want you to notice here is this idea that, see how we're just adding, it looks like we're adding two functions together. But we're not. We're adding the result of the functions. Whatever the functions come back with, that's what's getting added. And this is a concept that I want you to get your head
Wait,
around.
I'm trying to wrap around it.
I know.
Let me see.
Yeah, this is a tough one that a lot of people get stuck on, is this idea that when you're running a function like this,
Yeah.
it's the result, it's what comes back that you're doing something with. Because let's just take this for a sec. Let's take this and work it out the way that the computer works it out. Okay.
Yeah.
So I'm in order to do this, I'm actually going to draw it because I think it's going to make it easier to get the concept of what's happening.
Okay.
Okay. So we're going to say my total equals, and I'm going to shorten that function name to add. Okay. 3, 5 plus add, what was it, 5, 2?
Yes.
Okay. So what's happened? This is a long line of code that does actually quite a lot of things.
Oh, it was 5, 3, but I don't know.
Okay,
if it
sure.
matters.
We'll turn that into a 3.
The other one.
Oh, the other one was
Yeah.
5? Okay, fine. Well, whatever.
Whatever.
I'm not going to deal with that. Okay. So first, let's look at what happens. So the first thing it's going to do is it's going to replace this. Oops. Somehow. There we go. All right. So then this line of code in the computer becomes my total equals, what is the result of this? What does the number that got returned
8.
back? 8.
Yeah.
So this becomes 8 plus add 5, 2. Then it's going to do the next step, which the next step is do this. So what this goes off and runs its code, and what does it come back with?
7.
Right. So then this line of code becomes my total equals 8 plus 7. Now what? It's going to now do this line of code. And it ends up with my total
15.
equals 15. Then it's going to do the equal sign and take what's here and put it in here. You see how it does each of those steps as it goes?
Yeah.
You get the idea?
Yeah, I get that.
Yeah. And so you can actually think of this. You can think of add 3, 5. You can treat it like any other number.
Yeah.
Like in here, I'm just treating it like a number that's doing addition.
Okay.
Because it comes back with a number.
Yeah.
If it came back with a string, I could treat that function right there like a string.
Like a string.
I could put int around it. I could, add it to other strings, whatever, as long as that's what it comes back with. If it comes back with a string, I can treat it like a string as if I had put quote, hello, quote, you know what I mean?
Yeah.
Here, it's an integer, it comes back, I can treat it like any other integer. I could multiply it, divide it, but you have to understand that the computer is going to go through and run all the code step by step. And that's why I was saying, like, even though this is one line of code, it's actually doing like 4 or 5 steps.
Yeah, okay, yeah, I get it.
Okay, good.
Mm-hmm.
All right. Okay, so now we have a function that returns something. And you can see, this is a really simple function, right? Mm-hmm. It only does, this little bit right here. It doesn't have to do just that little bit. It could do a lot if it wanted to. We could have like hundreds of lines of code in this function that it does, just based off of what it's given. The other thing is that it doesn't always have to return something. Okay, so for example, let's make a function called shout. And it's not going to have any data that you give it.
Okay.
We're not going to give it any data.
Okay.
Okay, and we're just going to print hello. I am obnoxious. You don't have to spell obnoxious if you don't want to. I had to think about it as I wrote it. Mm-hmm. It is today, right now. Mm-hmm. I told you, it's obnoxious, right? Okay, so that we have a function. Now, is it giving back anything?
No.
No.
Mm-hmm.
It's not giving back anything.
Yeah.
So we can't really, use this in, like, we couldn't use it here because it's not giving back anything, right?
Yeah.
Like, it just does something.
Yeah.
Okay? Now, what we can do is we can run that function just straight up. We don't have to print it. We don't have to do anything. We can just type shout like this, right?
Okay.
And now watch what happens. It worked. It did it.
Shout.
We just do shout, parenthesis, parenthesis.
Boom.
Now, what happens is, as it's going through and running each line of code, it says, oh, shout, that's a function. I'm going to go run that. So it goes up to shout and then says, okay, well, run this line, run this line, run this line, and then come back and keep going. So it did. It popped up here, it printed, print, and then came back and then kept going.
Nice.
Now it got to the end, so it ended. But you see up here, it jumped up here. It did this line of code. It did this line of code, which tells it, when you go back, bring this number with you. So it brings this number, which means that it can then keep going on to the next piece of thing, which that brings back it, So this is useful when it returns something, but this might be useful when you want to just do something. And sometimes that matters because, like, for example, think of these questions. Tell me a number between 1 and 10.
7.
Good. So did you give me back information?
Yes.
So you returned 7.
Yeah.
Okay. So that function was tell me a number between 1 and 10. It means give me back info. Now, if I say think of a number between 1 and 10.
You're not asking for
I'm not asking for information back. I'm still asking you to do something.
Yeah.
Yeah. Okay. Does that make sense?
It makes sense, yeah.
Okay, good. Now, the other thing is that I want you to see something else. So I'm going to get rid of this shout thing because it's obnoxious. And I'm going to get rid of it. Now, also watch. If I try to run it and I don't have that definition there, look what happens. It gives me an error.
Boom.
The other thing I want you to see, because we haven't really talked about it much, is but in these errors, I don't understand all the stuff that's happening in the error.
Yeah.
But what I can see is, it thinks it's happening on line 13. And this is generally kind of what it thinks it's name shout is not defined. But the main thing is that line 13, that's where my error is. Okay, well, what's on line 13? Shout. And what does it say? Name shout is not defined? Oh, I didn't define shout. You see what I mean? Like, you can kind of, like, suss out what the meaning is based on that. But
that's really good. It shows you.
Yeah, but the really important thing is it tells you, like, what line of code. And that usually will give you an indication of where it is. Nice. So we're going to get rid of that. But now we're going to make another one called subtraction. And this is where, notice I'm also calling these A, B.
Okay.
And I'm going to say total equals A minus B. return total. And then I'm going to change my second addition here to subtraction. And we're going to leave the numbers. Doesn't matter.
Boom.
And then we run it, and it works fine. It works exactly as expect. 8 plus 3 minus 2 should be 11, right?
Oh, yeah, I didn't change that. Subtraction.
Yeah, oh yeah, make sure you change this one to subtraction. So it's an addition plus subtraction.
Boom, there it
is. Okay,
yeah.
So here's the thing that I want you to notice. Notice we're using the names A and B in both of these.
Yeah.
That's because it doesn't matter that these are the same, because this A and B is meant for this function.
Yeah.
After this function, A and B can be something else. Okay?
Yeah.
And here, same thing with total. We're making a variable called total, and it works in this function.
Nice.
But this total variable here works for this function. So it's okay that they're named the same in separate functions. Okay? And the fact that we're calling it A and B is just where these numbers are getting stored.
Yeah.
Okay? These numbers, or these variables up here, are called parameters.
Okay.
Okay? And parameters are the things needed as information to do something, you know?
Okay.
Like the parameters of a job are like, oh, you're going to be doing it for this long and you need to know this information, and, you know, or the parameters of that work request are, it's a, you know, repair job on an AC, you know, like whatever it is. And, you know, the parameters are just like the information that you need to know. Now, this actual data, like 5 and 2 and 5 and 3 and 12 and 4, those are called arguments. And what an argument is the actual information you're giving to the parameters.
Okay.
So there's it's a really subtle difference, but I want you to know the difference, because you'll see, if you ever, you know, go learn more programming stuff, you're going to see those words used.
Yeah.
Like, you know, 12 and 4 are arguments. That means they're the actual data you're giving to the function. Parameters are the slots that the data falls into when it gets it.
Yeah.
You get the idea?
Yes. I
So
do.
you'll even sometimes see them used interchangeably. Like sometimes people will call these things arguments. Like, oh, this argument is added to this argument. Okay, technically that's true, you know, sure. But you don't really have to get hung up on that. Wait, I thought that was a parameter. You know, it's like, or, you know, 12 and 4 parameters. Okay, fine. Doesn't really matter. They're just, they're kind of two names for the same thing, but there's a really subtle difference.
Okay.
Okay? Okay, so we now have functions that we can do all sorts of stuff in, and you can make really complex functions, like I said. Like, you know, our input stuff that we were doing, you can put all that in a function. Anything you find you're doing more than one time, you can stick it in a function, then you only have to write it once. And then you can get stuff back. And so, like, a lot of times games will do that all the time. Like, you might have a parameter for, you know, damage, which means that you take in which thing's getting damaged and how much should it get damaged. And all that function does is it says, oh, this thing's getting damaged, good. Take this, subtract that from its health, and send it back. Nice. You know what I mean? Yeah. And then you don't have to write a bunch of code for every single thing when it gets damaged. You just say, send it to the damage function, and here's how much to damage it. You know, and then it just runs that same code however many times you need.
That's awesome.
Okay. Yeah. Any question about that?
No.
Okay. Yeah. One thing is you do have to write the definition of the function before you use it. Yeah. Because it starts at the top and goes down. And if you try to use a function before you've defined what it is, it will have problems. Not all programming languages are like that. Some languages will look at all of your code at once and kind of run it more like, okay, yeah, you did include it over there. Okay, fine, you know. Nice. But most code is like in Python, for example, it's starting from the top and going to the bottom. Okay. So we covered a lot in this last section. Yeah. So we covered lists and we covered functions. Yeah. Okay. These concepts that we just covered is the building blocks of code. Okay. All code is, like when you really get down to it, it's messing with variables using functions. Yeah. That's like if you take any program and you could distill it down to that sentence. It's messing with variables using functions. And so if you can take your code or someone else's code or even some program that you're trying to figure out, like, how does this work? Yeah. Well, you can kind of figure out, okay, what are the functions it has? What are the things that it does? Yeah. What are the variables that store the information? And how is it messing with those variables using these functions? And sometimes it gets pretty complex.
Yeah.
You know, like there's some really complicated stuff that is done even in like, you know, basic games.
Yeah.
But it really comes down to that concept
Nice.
of messing with variables using functions.
Awesome.
Alrighty?
Yeah.
Okay, good. So this was Python. And I like Python because it's fairly easy to use, and also it's like super easy to look stuff up. Like, let's say if you need to learn how to reverse a list, you can just literally just type in
Google.
Python reverse list, and then I'll copy and paste that code and stick it in here.
Nice.
And there's lots of people out there willing to help.
Nice.
But there's lots of languages for different things. Like, remember I told you Python is really good at lists?
Yeah.
There's other languages that are, you know, really good at dealing with like computer memory. You know, like like where it's storing stuff in the computer, and you can do like tons of stuff with, you know, with the computer memory really well. There's other ones where they don't care about the memory, and they'll just you never have to think about that.
Yeah.
There's other programming languages that are really good at dealing with text. There's other programming languages that are really good dealing with like structures of information. Like you have like a person, and they own this, and they have, you know, like for games, you know, you might have like, oh, you have like an enemy, and you have different types of enemies, and you have vehicles and different types of vehicles, but those are all mobile things, and, you know, like they're just different ways of. So this is a question: how can you tell what language is good with what? Does the documentation mention it somehow? Sometimes. So often you'll find that the languages that are good for different things have lots of things made in those languages. Like, for example, Python, you don't find a lot of games written in Python. It just doesn't tend to be a language that works well for games.
Yeah.
You know? C++, there's a lot of games written in C++. You know? Unreal, you know, you've heard Unreal Engine?
No. Oh, Unreal, yes.
Yeah. Unreal Engine, it's coded with C++. And that language works well for games.
Nice.
Unity uses language C# for games because it works well for Unity games. So that's generally how you'll see like what a language is good for, is find out what kind of things are being written in that. Like machine learning is something that Python is used a lot with, you know, because Python is good at working with data. You'll find lots of science programs are written with Python, you know. So sometimes the language will tell you, but oftentimes you can use Python for writing games.
Yeah.
I've seen really cool games written in Python. But does it do really well, and does it generally get used for that? No, not really, you know. But usually you can use a language for pretty much anything, you know. Does that answer your question, Hats, please? So, anyway, do you have any questions?
No, I mean, I definitely learned a lot.
Okay, good.
Yeah, that was awesome.
Okay, good. Well, that's all we're going to cover for this workshop. I did want to mention a few things, though, of where to go from here. Okay. So, for example, there's lots of places online. Like, if you just search for, like, Python tutorial, now you got to practice. So, if you search online for Python tutorials, you'll find tons. There's YouTube videos. There's written articles. There's, like, whole, like, courses you can do, you know. You'll find whatever method of learning works well for you, you'll probably find someone teaching it that way.
Nice.
And my suggestion is find something you want to do and learn how to code with that in mind, where you're trying to learn how to do that thing. Because if you're I've seen a lot of people where they try to learn a language and they strictly are learning the language. And that's it.
Yeah.
It's tough because you don't really have something you're using it
so
for.
Broad.
Yeah, it's so broad, and it's also, you might read one thing and you might be like, well, I don't really know how I'm going to use that. Okay, I guess I should remember it, and it's hard to remember. But then if you have a thing that you're doing and you read some piece of code or how to code something, and you're like, oh, I can use that for doing this kind of thing. You have like an immediate thing to attach it to, and you have something that you can then.
That's cool.
Like when I was a kid learning algebra, algebra is a tough subject for a lot of people because most people are like, when am I ever going to use this? You know, and sure, you might like maybe 10 years down the road have, you know, some use for algebra. By that time, you're 10 years away from when you just learned it. You know, so it's like, well, I got to learn that again. But I was learning how to program when I was first learning algebra. And I was learning how to do things like make a gravity simulator and, do like some neat games. But the thing was, like, I had these ideas of things I wanted to make. And so that when I was learning algebra, I was like, oh, I can use it. And I was like, I almost couldn't wait to finish math class just to like go use the thing I just learned and then that thing was cemented in because I literally went and used it right after learning it, so
that's awesome.
Having a project really, really, really helps.
Yeah.
The other advice though is don't make it too big of a project. Like if you're like, I'm going to build the next Uber and or I'm going to make the next, Red Dead Redemption, and it's like, that has like, literally hundreds of people working for like 5 straight years. You know what I mean? It's like, have a smaller project now. Like I'm gonna do Breakout or Pong, and like start small, and then you'll like start learning bigger things.
Nice.
Anyway, any other questions?
No, but I'm thinking about doing that like a little choice game or something.
Oh yeah,
super simple.
Yeah,
you make this choice.
I mean, the text adventure games can be super fun to make in Python because it's like you're just keeping track of like a few variables and you're just asking the user questions. Yeah. So I used to think I could solo build WoW. Yeah, that's a lot of work. Yeah, I mean, sometimes all you have to do is if you have a game in mind, or like a game in mind you want to play, and there's another game that's similar. It doesn't have to be the same, but it's similar. Go look at the credits for that game. The whole credits. Don't skimp. Watch the whole credits. And then realize, or you can even sometimes go look up how long it took them to make it.
Yeah.
Right? So, for example, the credits for Diablo 3. If you just watch the credits, and they're scrolling by pretty fast, like there's like each person's name is only on screen for a few seconds, right? I think the credits, watching them, just sitting there watching them, was 22 minutes.
Oh Lord!
And they were working on that game for 11 years. So that many people working for 11 years, and you have the kind of idea like, okay, that's about how much work it takes to make Diablo 3. You know what I mean? Okay, so like keep that in mind.
Sure.
Yeah. Okay, any other questions from the chat? If so, type them in. If not, thank you for joining us. I hope you got something out of this. And JJ, I'm glad to hear you got something out of it.
Course, yeah,
I am always available if you want to ask me questions. I mean, you can just come see me, but anyone else, I'm available on Twitter. There's the PIGSquad Discord is also available. We have a programming channel. You're always welcome to ask questions. There's a lot of helpful, friendly people in there. If you ask me, send me a DM on Twitter. I'm happy to help as well. So yeah, I think that's about it. We have just some PIGSquad wrap-up stuff. We have a game jam happening in just a short amount of time here in August. It's for our summer slow jams. Yeah, the technical jam theme is cliffhanger, so you can find something to do there. I love the idea of cliffhanger as a jam theme because it's like so many jam games are like really short and tight focus. So you could like build up like this amazing thing's about to happen and you leave them hanging on that cliff at the end of the jam game. So you keep the scope small, but then it's like, oh my gosh, this huge thing's gonna happen. And yep, we have a speed meetup coming up on Friday, it's a virtual speed meetup. It's gonna be happening in a virtual space, which is really cool because it's all like distance-based voice chat. So like as you walk towards people in the virtual space, you can hear the conversation. As you walk away, they fade out, and they're like little separate rooms you can go into. Anyway, it's gonna be really cool. It's a brand new tool that's out now called Skittish, and it's pretty cool. We got to try it out before the event. All right, Will, is anything else I'm forgetting? See, now you get to be on the other side of this, of having me ask anything else I'm forgetting. Will does so many of our online events.
Oh, wow.
Yeah. All right, well, I think that's about it. If you're interested in supporting workshops like this, we have a Patreon, patreon.com/PIGSquad, and helps make workshops like this available. This workshop will be available as a VOD on Twitch, and we will also probably be uploading it to YouTube as well. So you can keep an eye out for there if you missed part of this or want to watch it again. I find that when I'm learning a new thing, going through like a tutorial 2-3 times is really helpful. So feel free to walk through this as many times as you'd like. And thank you very much, JJ, for coming to join. I really appreciate that. It makes this workshop a whole lot easier to deliver. All right, thanks everybody. We're gonna sign off now. Bye-bye.